What is good, everyone, and welcome back. Today we are building and deploying Project Alabama from scratch. Project Alabama is a full-stack AI security operations console. It ingests enterprise log files, detects insider threats using rule-based anomaly detection, and uses Google Gemini to turn raw security alerts into plain language analyst reports. Next.js on the front end, Prisma and Neon on the back end, and Gemini handling the AI layer. We are going to go through the entire code base, demo the finished app live, and then deploy it to a real domain using Hostinger, who are sponsoring today's video. This is a long one, so let us not waste any time. Let us get into it. Before anything else, quick word from today's sponsor, Hostinger. We are using Hostinger to deploy Project Alabama today, and I want to show you exactly how the process works because it is genuinely straightforward. Head to hostinger.com. Link is in the description. You want the cloud hosting or VPS plan. For a Next.js app like this one, the cloud plan is the right starting point. It handles the build pipeline, gives you enough resources for real traffic, and the pricing is very fair. Click Get Started, pick your plan, and when you hit checkout, use my coupon code in the description. It gets you a solid discount off your first purchase. Make sure you apply it before you pay. Inside the Hostinger dashboard, you connect your GitHub repository, set your environment variables, and hit deploy. For Project Alabama, that means 4 environment variables: database _ URL, direct _ URL, Gemini _ API _ key, and Gemini _ model. It pulls your code, installs dependencies, builds the app, and serves it. No custom config files, no build scripts to write. What I like about Hostinger specifically for a project like this is the visibility. Logs are right there in the dashboard. If a build fails, you see exactly why straight away. And when the app is live, monitoring is built in. Link is in the description. Coupon code is right below it. Now let us build the thing. Before we walk through the code, let me show you what we are building so you know exactly where we are headed. This is Project Alabama running live. The Alerts tab is the main view. At the top, you have 4 KPI numbers: total events ingested, total alerts, open alerts, and critical alerts. The open pressure bar gives you a quick visual on how much active risk is sitting in the system right now. Let me hit seed demo to load the curated dataset. Watch the dashboard populate. You can see alerts appearing in the list in real time. Click on any alert and the detail panel opens on the right. You can see the user, the trigger event, the device, the IP, and the location. Below that are the detection signals, the specific rules that fired, and why this alert exists. This one has 2 signals firing together: download spike and off-hours privilege action. The combined risk score pushes it to high severity. Now click Generate Explanation. This calls Gemini. In a moment you get a headline, a full analyst-style write-up of what happened, and 3 concrete recommended next steps. Gemini is reading the actual alert context every time. This is not a template. So now, over on the Log Upload tab, you can drop in a CSV, JSON, NDJSON, or key value log file. The parser auto detects the format, normalizes the rows, runs the detection engine, and Gemini summarizes the upload with the top risks found. The raw ingest tab lets you paste JSON directly. The sample payload in there already triggers 2 detection rules simultaneously, so you can see it fire right away. That is the finished product. Now let us build it. We are about setting up Project Alabama. This is a security operations console built with Next.js, Prisma, and Neon as the database. By the end of this video, we will have the full app running locally, and we are going to walk through every major file in the code base so you know exactly how everything fits together before we start building. Let us get into it. We start by cloning the starter repo. Head to your terminal and run git clone with the Alabama starter repository URL. This pulls the entire project scaffold down to your local machine. Once that is done, change into the project folder and run npm install. This pulls in all the dependencies. Next.js, Prisma, the Neon driver, everything the project needs. Depending on your connection speed, this might take a minute, so just let it run. While that finishes, we need to set up our environment variables. Create a new file in the project root called .env.local. This is where all sensitive config lives. Database URLs, API keys, anything that should never get committed to Git. The git ignore in the starter repo already excludes this file, so you are safe. Now for the database, open your browser and navigate to the Neon console. If you have not used Neon before, it is a serverless Postgres provider. It works really well with Next.js because it handles connection pooling automatically. Create a new project and name it Alabama-Proj. Once it is created, Neon gives you a connection string. Copy that string. Go back to your .env.local file and paste it in twice. Once as database_URL and once as direct_URL. So the reason we need both is that Prisma uses database URL for the pooled connection and direct URL for running migrations directly. If you only set one of them, your schema push will fail. So make sure both are there. Now run npm run Prisma generate. This reads your schema file and generates the typed Prisma client. All the TypeScript types and query builders you will use throughout the app get created here. Anytime you change the schema, you need to rerun this command. Next, run npm run Prisma push. This takes your local schema and pushes it to Neon, creating all the tables in the database. In a production setup, you would use migrations instead, but for local development, push is the fastest way to get your database in sync. Alright, everything is wired up. Run npm run dev to start the development server. Open your browser and go to localhost 3000. Now, you should see the Alabama Security Ops console load up. Take a look at the tabs across the top. We have alerts, log upload, raw ingest, and integrations. Each of these maps to a distinct feature area that we will be building out in upcoming sections. Now let us walk through the code base. Open prisma/schema.prisma. This is the heart of the data layer. It defines 4 core models. The event model represents normalized log entries, things like user logins, file downloads, and API calls. Raw activity from various sources gets normalized into this shape. The anomaly model captures rule violations. These are individual suspicious behaviors that the detection engine has flagged. The alert model aggregates those anomalies. When multiple anomalies cluster around the same user or the same time window, they get promoted into an alert that an analyst actually needs to act on. And finally, the integration connection model stores configuration for external services, things like connecting to a SIEM or a ticketing system. Next, open lib/types.ts. This file contains all the TypeScript interfaces and enums used across the application, entity shapes for events, anomalies, alerts, and integrations, plus enums for event types and severity levels. Anytime you want to understand what shape a piece of data has as it moves through the app, this is the first place to look. Quick one now. Open lib/db.ts. This just initializes the Prisma client using a singleton pattern. That means you are not creating a new database connection on every single request. This matters a lot in a serverless environment like Next.js. Now open lab/detection.ts. This is where the interesting stuff lives. This file contains the logic for all the security detection rules. Each rule has a name, a condition, and a scoring weight. For example, impossible travel. If a user logs in from two geographically distant locations within a short time window, that gets flagged. If a user downloads an abnormal volume of data in a short period, that scores high as well. These weights feed directly into the anomaly scoring system. So now open lib/store.ts. This is the data access layer. All your CRUD operations live here, creating events, querying alerts, updating statuses. The rest of the app calls functions from this file rather than writing raw Prisma queries in line. It is a clean separation that makes the code base much easier to test and maintain. Now this one is really cool. Open lib/gemini.ts. This is the Gemini AI integration. When an alert is generated, instead of just showing raw data to the analyst, the app calls Gemini to produce a natural language explanation. So instead of a list of anomaly scores, the analyst sees something like, this user accessed sensitive files from an unrecognized location immediately after a failed login attempt. That kind of context is huge for how fast an analyst can triage an alert. Last two files, lib/log-file.ts handles parsing for uploaded log files. Different log formats come in from different sources, and this file normalizes all of them into the event shape we saw in the schema. And lib/integrations.ts manages the connection logic for external services, authentication flows, API calls, and status checks for anything connected through the integrations tab. Next up, the API routes. Open app/API/ingest/upload/route.ts and app/API/ingest/route.ts. These two endpoints are responsible for taking in security log data. The ingest route accepts raw JSON payloads directly, while the upload route handles file uploads in formats like JSON, CSV, and NDJSON. Both routes need to validate the incoming data, normalize it into a consistent shape, run the detection engine against it, and finally persist everything to the database. You will see to-do comments throughout marking exactly where each of those steps goes. Now open app/API/alerts/route.ts. This is a get endpoint. It fetches all alerts from the database, ordered newest first, and also pulls system-wide stats like total event count, open alerts, and critical alerts. The dashboard pulls this every 12 seconds to stay current. Next, open app/API/alert/id/explain/route.ts. This is where the Gemini AI integration lives. When an analyst clicks Generate Explanation on an alert, this endpoint takes the full alert context, including the anomalies that triggered it, the event metadata, and the risk score, and sends all of that to Gemini. Gemini returns a plain language explanation plus suggested next steps. And if Gemini is unavailable for any reason, the app falls back to a deterministic rule-based summary, so the experience never breaks. Next, briefly check the three utility routes. App/API/integrations handles cloud provider connection state. App/API/seed resets the database and loads a created set of demo events designed to trigger all four detection rules. And app/API/reset wipes everything clean so you can start fresh. Now let us move into the state and component logic. Open hooks/use dashboard state.ts. This custom hook is the brain of the entire dashboard. It owns all React state, all API calls, and all derived values. When you look at the page.tsx file, it is intentionally thin. Its only job is to call this hook and pass the results down to child components. That keeps all the business logic in one testable place. Open app/page.tsx. As I said, this file is intentionally thin. It calls use dashboard state once at the top, then renders the layout shell. The sidebar on the left, the top bar across the top, and the main content area in the center. 4 tab views are conditionally rendered based on which tab is active. Open components /dashboard/sidebar.tsx. This is the fixed left navigation column. It renders the app logo, the 4 nav tabs, quick action buttons at the bottom for the AI session and connecting apps, and a footer showing the currently active Gemini model name. The sidebar holds 0, local state, everything is driven by props. Open components /dashboard/topbar.tsx. The top bar shows the current tab title, an alert count badge on the alerts tab, a toast message showing the last operation result, and the seed demo and reset buttons. Seed demo calls post/API/seed. Reset calls post/API/reset. Now we are implementing the data access layer for Project Alabama. This is the lib/store.ts file, and it is the single most important file in the entire backend. Every API route talks to this file instead of calling Prisma directly. That means all database logic lives in one place and the routes stay clean and small. Let us get into it. Alright, we start by importing the 2 functions we need from the detection module. Run detections and build summary from lib/detection.ts. Run detections is what actually analyzes an event and decides whether it is suspicious. Build summary turns the triggered rule names into a human-readable sentence for the alert. Next, we define 2 internal TypeScript interfaces that mirror the shapes Prisma returns from the database. The first is the event. This is what a raw database row looks like when you pull an event from Prisma. Timestamps come back as JavaScript date objects, not strings, so we need this interface to handle the conversion cleanly. Now, the second is DB alert with anomaly, IDS. This represents an alert row joined with its anomaly links. When we fetch an alert from the database, we get the alert fields plus an array of anomaly ID references. We use this interface to map that shape safely before returning it to the API layer. We also define a few helper functions. Normalize event takes a raw ingest event and fills in any missing fields with sensible defaults. Unknown device becomes the string unknown-device. Unknown IP becomes 0.0.0.0. Unknown geo becomes the string unknown. This means the database schema never has to deal with nulls in those fields. Event2type converts a raw Prisma database row back into the normalized event TypeScript type, converting the date objects to ISO strings along the way. And alert2type does the same thing for alert rows. Now for the main function, ingest events. This takes an array of ingest event objects and processes them one at a time. For each event, it does 4 things. First, it normalizes the raw input using our normalize event helper. Second, it calls prisma.event.create to persist the normalized event to the database. Third, it loads all existing events for that same user from the database. This is important. The detection engine needs the full event history to evaluate temporal rules like impossible travel and download spike. You cannot detect whether travel is impossible if you only have one login. Fourth, it calls run detections with the new event and the full user history. If any anomalies come back, it creates anomaly rows in the database and then creates a linked alert row that ties them all together. At the end, it returns both the ingested events and any alerts that were created. So the API route can report back exactly what happened. Now we have list alerts. This fetches all alerts ordered newest first. Each alert row is joined with its anomaly links, so we know which anomalies triggered it. We then map everything through alert to type to get clean TypeScript types back. Now the get alert with context does more work. This is what powers the detail panel on the right side of the dashboard when an analyst clicks on an alert row. Update alert is simpler. It takes an alert ID, an optional new status, and an optional note string. If a note is provided, it gets appended to the existing notes array. The updated alert is returned, so the dashboard can refresh the detail panel immediately. Reset store deletes everything in the correct order to respect foreign key constraints. Finally, seed demo events. This function builds a curated sequence of demo events designed to trigger all 4 detection rules in a realistic way. For the download spike rule, we create 11 download events for a user named Alice, all within a 30-minute window. Next, we are wiring up all the API routes for Project Alabama. In the last session, we built the data access layer in lib/store.ts. Today, we connect it to the outside world. By the end of this video, the dashboard will be fully live. Data will flow in from the browser, get detected, get stored, and come back as alerts. Let us get into it. Start by opening app/api/ingest/route.ts. This is the raw JSON ingestion endpoint. It accepts a post request containing an array of log events and runs them through the entire ingestion pipeline. So before we call anything on the store, we need to validate the incoming payload. We write a type guard function called isEvent. It takes any unknown value and checks 3 things. First, it makes sure the value is an object and not null. Second, it checks that user ID is a string. Third, it checks that event type and action are both strings. If all 3 pass, TypeScript now knows the value is a valid ingest event, and we can use it safely. Now for the post handler itself, we pass the JSON body from the request. The body can come in 2 shapes, either a plain array of events or an object with an events array nested inside. We handle both by checking if the body is already an array, and if not, we try to pull body.events. So if the array is missing or any item fails the isEvent check, we return a 400 error with a clear message explaining the expected shape. No silent failures here. If validation passes, we call ingest events from the store. That function normalizes each event, saves it to the database, runs the detection engine, and creates alerts for anything suspicious. We return the ingested count, the alert count, and the created alert directly in the response. Now open app/api/alerts/route.ts. This is the get endpoint. The dashboard polls every 12 seconds. It needs to return 2 things at once: the full list of alerts and the system-wide KPI stats. We use promise.all to fetch both in parallel. Get system stats and list alerts run at the same time instead of one after the other. On a code request that could save 100 milliseconds or more. We also set the dynamic export to false dynamic at the top of the file. This tells Next.js to never cache this route because alert data needs to be fresh on every request. The response shape is simple: a stats object and an alerts array. Now open app/api/alerts/id/route.ts. This is the dynamic route for a single alert. It has 2 handlers. The get handler takes the alert ID from the URL params, calls get alert with context from the store, and returns the full alert with its anomalies, the trigger event, and the related event timeline. If no alert is found for that ID, we return a 404. The patch handler lets analysts update an alert. We pass the body for two optional fields, status and note. We have a small statuses constant array containing the three valid values, open, investigating, and resolved. If the client sends a status value that is not in that array, we reject it with a 400 error immediately. If validation passes, we call update alert from the store and return the updated alert. Next, we are building the AI layer for Project Alabama. This is the feature that takes a raw security alert and turns it into something an analyst can actually act on. Instead of staring at a list of anomaly scores, the analyst gets a plain language explanation of what happened, why it is suspicious, and exactly what to do next. All powered by Google Gemini. Let us get into it. Start by opening lib/gemini.ts. Before writing any logic, we define the two TypeScript interfaces that describe what this module returns. The first is explanation result. This is the shape of the AI response for a single alert. It has four fields: a headline, which is a short one-line summary of the threat, an explanation, which is the detailed analyst-style write-up, a next steps array, which contains exactly 3 recommended actions, and a meta object, which tracks which Gemini model was used, whether the fallback was triggered, and any error message if something went wrong. The second is upload insight result. This is the shape for the upload summary feature. It has a summary string, a risks array of up to 3 items, and the same meta object. These interfaces are important because they give the rest of the app a guaranteed contract. Whether the response comes from Gemini or from the fallback, the shape is always identical. Now we handle the API key and client setup. Open the browser and go to AI Studio at aistudio.google.com. Create a new API key and copy it. Back in the project, open .env.local and add a new line. Gemini_API_key equals your key. Optionally, you can also add Gemini_model to set a default model. If that variable is missing, the code falls back to Gemini-3-flash-preview. Back in Gemini.ts, we import Google Gen AI from the @google/Geni package. Now we write the fallback function. Fallback explanation takes an alert with context and a meta object. It builds a deterministic response from the data we already have without calling Gemini at all. The headline uses the risk score, severity, and user ID. The explanation lists the anomaly reasons line by line, then adds the trigger event action and resource. The next steps are 3 standard investigation steps that apply to virtually any insider threat scenario. Validate the account owner, initiated the activity, check endpoint and identity logs for compromised credentials, and review the timeline for lateral movement and data exfiltration patterns. This fallback is not a placeholder. It is a real useful response. The goal is that even with no Gemini API key at all, the feature still works. Now the main function, explain alert with Gemini. It takes 2 arguments, the full alert with context and an optional model override string. The model resolution order is the override if provided, then the Gemini_model environment variable, then the hard-coded default. Before doing anything expensive, we check 2 things. First, is the API key present? If not, return the fallback immediately with an error message saying the key is missing. Second, is the model name format valid? We run it through a simple regex that allows letters, numbers, dots, hyphens, and underscores. between 3 and 120 characters. This prevents injection attacks and catches obvious typos before they reach the API. If both checks pass, we instantiate the Google Gen AI client and build the prompt. The prompt is an array of strings joined with new lines. We start by telling Gemini it is a senior SOC analyst for insider threat detection. We tell it to return strict JSON with exactly 3 keys: headline, explanation, and next steps. We give it explicit rules. The explanation must be concise and actionable. Next steps must contain exactly 3 short strings, and there must be no markdown, no code fences, only a raw JSON object. Then we append the full alert context serialized as JSON. Now we handle the response. After calling AI.models.generate content, we get back a response object. We pull out the text field and trim it. Here is where extract JSON object comes in. AI models sometimes wrap their response in markdown code fences like triple backtick JSON. Extract JSON object strips all of that away. It first checks if the text already starts and ends with curly braces. If it does, it returns it as is. If not, it uses a regex to find the first JSON object shape in the string, pulling just the part between the outermost curly braces. We pass the cleaned text into safe pass explanation. That function calls json.pass inside a try catch. After passing, it validates that the result has a headline string, an explanation string, and a next steps array where every item is a string. If any of those checks fail, it returns null. If safe pass explanation returns a valid result, we spread it into the return value and attach the meta object with used fallback set to false. Done. If it returns null, meaning the model returned something we could not pass, we call fallback explanation with an error message saying the model response was not valid JSON. So now, if the entire API call throws an exception, we catch it and call pass Gemini error. That function looks inside the error message for a structured Gemini error payload. The second exported function is summarize upload with Gemini. It works almost identically, but is designed for the log file upload feature rather than individual alerts. It takes the file name, the detected format, the event count, the alert count, and an array of the top alerts as context. And that is the complete Gemini integration for Project Alabama. 2 exported functions, a robust fallback that always produces a usable result, strict JSON prompting to keep responses consistent, a regex-based JSON extractor to handle markdown wrapping, structured error, passing with human-readable messages, and a model name validator to prevent bad inputs reaching the API. Now open app/api/alerts/id/explain/route.ts. This is the post endpoint the dashboard calls when an analyst clicks generate explanation. It reads an optional model field from the request body wrapped in a try catch because the body is genuinely optional. It calls get alert with context to load the full alert with its anomalies and related events. If the alert does not exist, 404. Otherwise, it passes everything to explain alert with Gemini and returns the result directly. Now the log file parser, openlib/log-file.ts. The main export is pass uploaded log file. It takes the raw file content as a string and tries 4 parsers in order until one succeeds. The parsers are parser.json, parser.ndjson, parser.csv, and parser key value logs. We are building 2 more API routes for Project Alabama. The AI explanation endpoint that powers the generate explanation button in the dashboard, and the integrations management endpoint that handles connecting and disconnecting cloud providers. Short video today, but both of these routes tie together a lot of the work we have done in previous videos. Let us get into it. Now open app/api/integrations/root.ts. This route handles two things: listing all integration connection states and creating or updating a connection. Start with the imports. We need list integrations and upset integration connection from lib/integrations.ts and the integration provider and integration status types from lib/types.ts. At the top of the file, we define two small constant arrays. Providers contains the 5 valid provider names: AWS, GCP, Azure, GitHub, and Slack. Statuses contains the 3 valid status values: connected, disconnected, and error. We use these for validation in a moment. The get handler is simple. We call list integrations and return the result wrapped in a JSON object with an integrations key. The interesting thing about list integrations is what it does when a provider has never been configured. Rather than returning an empty list, it returns a virtual disconnected record for every provider that is missing from the database. So the get handler always returns exactly 5 cards, 1 for each provider, regardless of whether anyone has ever connected anything. The dashboard integrations tab always shows all 5 cards with their correct connection states. So now the post handler is more involved. We pass the JSON body inside a try catch. If the body is not valid JSON, we return a 400 immediately. Then we validate 2 fields. First, provider. It must be present and must be one of the 5 values in our provider's array, if not 400. Second, status. It must be present and must be one of the 3 values in statuses, if not 400. These 2 checks are the entire security boundary for this endpoint. If a caller tries to pass an arbitrary string like super secret cloud or an invalid status like pending, they get rejected before anything touches the database. If both fields are valid, we call upset integration connection with the provider, status, display name, and metadata from the request body. In the next session, we do a full end-to-end live test. We seed the demo data, generate AI explanations for real alerts, upload a CSV log file, and watch everything flow through the dashboard live. This is Project Alabama running live. The Alerts tab is the main view. At the top, you have 4 KPI numbers: total events ingested, total alerts, open alerts, and critical alerts. The open pressure bar gives you a quick visual on how much active risk is sitting in the system right now. Let me hit seed demo to load the curated dataset. Watch the dashboard populate. You can see alerts appearing in the list in real time. Click on any alert and the detail panel opens on the right. You can see the user, the trigger event, the device, the IP, and the location. Below that are the detection signals, the specific rules that fired, and why this alert exists. This one has 2 signals firing together: download spike and off hours privilege action. The combined risk score pushes it to high severity. Now click Generate Explanation. This calls Gemini. In a moment, you get a headline, a full analyst-style write-up of what happened, and 3 concrete recommended next steps. Gemini is reading the actual alert context every time. This is not a template. So now, over on the Log Upload tab, you can drop in a CSV, JSON, NDJSON, or key value log file. The parser auto detects the format, normalizes the rows, runs the detection engine, and Gemini summarizes the upload with the top risks found. The raw ingest tab lets you paste JSON directly. The sample payload in there already triggers 2 detection rules simultaneously, so you can see it fire right away. That is the finished product. Alright, the build is done. let us get it live. Make sure your project is pushed to GitHub on your main branch. Confirm your .env.local file is not committed. Check your .gitignore and make sure env files are excluded before you push. Go to your Hostinger dashboard. Click Create New Project and connect your GitHub account. Select your repository. Hostinger automatically detects that this is a Next.js project. Before you hit deploy, go to the environment variables section and add your 4 variables. Database underscore URL, direct underscore URL, Gemini underscore API underscore key, and Gemini underscore model. Save the variables and click deploy. Watch the build logs. You will see Hostinger install dependencies, run Prisma generate, build the Next.js app, and start the server. When you see the build complete message, the app is live. Copy your deployment URL and open it in the browser. And that is Project Alabama fully built and live. Full stack Next.js app, Prisma on Neon, 4 detection rules, multi-format log file parsing, and Gemini-powered AI explanations, all deployed on Hostinger in one video. If you built this alongside the video, drop a comment with your deployment link. And if you want to see more projects like this, subscribe so you do not miss the next one. Hostinger link and coupon code are in the description. Use it. See you in the next one. What is good, everyone, and welcome back. Today we are building Interview Ninja from scratch. Interview Ninja is a full-stack AI-powered coding interview platform. Candidates sign in, browse live interview sessions, write code in a VS Code style editor right in the browser, and get instant AI feedback on their submission. Scores, strengths, weaknesses, time and space complexity, all generated by Claude from Anthropic in real time. On the recruiter side, you create sessions, add coding questions with difficulty levels and expected concepts, and watch candidate submissions come in live. The entire backend is powered by InsForge. Auth, database, storage, all in one platform. This is a long build, so let us not waste any time. Let us get into it. Let me walk you through the architecture diagram so you have a clear mental model before we write a single line of code. Looking at the diagram, everything starts on the left with the front-end layer. Inside it, you have 3 key pieces: the auth guard, the candidate dashboard, and the recruiter dashboard. The auth guard sits at the entry point of every protected route. When a user hits a candidate or recruiter page, the guard runs first. It checks the session, fetches the user profile from the database, reads the role field, and routes accordingly. If the role is candidate, it renders the candidate dashboard. If the role is recruiter, it renders the recruiter dashboard. If there is no valid session at all, it sends the user back to the login page. Also, inside the front-end layer, you can see the sidebar and the Monaco editor. The sidebar is role-aware. It shows candidate navigation to candidates and recruiter navigation to recruiters. The Monaco editor lives inside the interview session and is where candidates actually write their code. Moving down to the auth layer at the bottom left. The flow starts with Google OAuth. The user clicks continue with Google. Google handles the authentication, and the OAuth redirect lands at the auth callback page. The callback verifies the session through InsForge auth and issues a session token back to the front end. That session token is what the auth guard uses on every subsequent page load. Now look at the middle of the diagram. The API layer sits between the front end and everything else. The Next.js App Router acts as the route handler, directing traffic to the correct endpoint. The most important endpoint is post/API/evaluate. This is the route that runs every time a candidate submits their code. Following the arrows to the right from the evaluate route, you can see it connects to the AI layer at the top. The evaluation prompt goes to Anthropic Claude. Claude processes the code against the question context and returns a score and feedback JSON. If Claude hits a rate limit or is overloaded, the arrow shows a fallback path to the fallback heuristics function. This ensures the candidate always gets a response even when the AI service is having issues. The evaluate route also connects downward to the InsForge platform layer. Two things happen here. First, the raw code file gets uploaded to InsForge storage as a blob. Second, the score and feedback get written to the database via the REST API. Inside the InsForge platform, you can see the full data path. The REST API queries and mutates the Postgres database. The Postgres database enforces every query through row-level security before any data is returned. Row-level security filters by user ID, by session access, by recruiter ID, and by candidate ID depending on which table is being accessed. No user can ever see data that does not belong to them. The database enforces this regardless of what the API receives. On the far right is the database tables layer. 4 tables: candidate attempts table, users table, interview sessions table, and questions table. The arrows show how they relate to each other. Candidate attempts are filtered by candidate ID, users are filtered by user ID, interview sessions are filtered by recruiter ID, questions are filtered by session access, and questions belong to sessions, shown by the add questions per session arrow connecting those two tables. Looking at the arrows coming back from the database to the front end, you can see 3 return paths. Available sessions list goes back to the candidate dashboard, so candidates can see what sessions exist. View candidate results goes back to the recruiter dashboard, so recruiters can see how candidates performed. And fetch history and stats goes back to the candidate dashboard at the top to populate the submission history and KPI numbers. The final connection worth noting is the @insforge/SDK label on the arrows connecting the candidate dashboard and the recruiter dashboard directly to the InsForge platform. Both portals talk to InsForge using the same SDK client initialized in lib/insforge.ts. One client instance handles authentication, database queries, and storage for the entire front end. That is the full picture. Auth flows in from the left through Google OAuth and InsForge. Code submissions flow up through the API layer to Claude and back down as structured feedback. Data persists in PostgreSQL, with row-level security enforcing every access rule. And the SDK ties the front end directly to the back end for everything outside of AI evaluation. Now let us build it. Real quick before we dive in, we are deploying this on Hostinger, and I want to show you why I picked them for this project specifically. Interview Ninja is not a simple static site. It is making authenticated database calls on every page load and hitting the Anthropic API every time a candidate submits code. You need a host that can actually handle that without going down or slowing things up. Hostinger has been solid for me on projects like this. Let me show you exactly how the deployment works so you can follow along later. Go to hostinger.com and sign in to your account. Once you are inside, click on Website in the sidebar. This takes you to your website list where all your projects live. Click the Add New Website button. On the next modal, scroll down and select Node.js as your project type. This is important. Interview Ninja is a Next.js app, and it needs a Node runtime, not a static site host. Select it and continue. You will be asked to connect your GitHub account if you have not already. Connect it, then select the Interview Ninja repository from the list. Choose your main branch as the deployment source. Now before you hit deploy, go to the environment variable section. This is where you add your 4 variables. Next, public insforge URL set to your insforge project URL. Next, public insforge anon key set to your anon JWT from the insforge dashboard. Anthropic API key set to your Claude API key. And next, public app URL set to your production domain. Once all four are saved, click deploy. Hostinger pulls your code from GitHub, installs the dependencies, runs the Next.js build, and starts the server. You can watch the build logs in real time right there in the dashboard. When you see the build complete message, your app is live. Go to your assigned domain or custom domain, open it in the browser, and you should see Interview Ninja running exactly as it does on localhost. If you want to try it yourself, link is in the description. Use my coupon code ALBERTAI at checkout to get a discount on your plan. It is my personal code, so it helps the channel too when you use it. Alright, let us actually build the thing. Today we are building Interview Ninja from scratch. This is a full-stack AI-powered interview platform with two sides, a candidate dashboard and a recruiter dashboard. Authentication is handled by insforge. The UI shell is already set up, and by the end of this video, we will have the entire thing built, connected, and running live. But first, we need to get the starter project on our machine. Let us do that right now. Open a fresh terminal. Make sure you can see the current directory. We are going to clone the starter repository, so everything begins from the same point. Run this command: git clone https github.com /albert interview ninja starter. Git interview ninja. Let that output print on screen. Do not rush past it. You want to see the clone complete before moving on. Before we install anything, let us see what we are working with. Run ls. You should see the following: src public package.json, next.config.ts, tsconfig.json, .env.example, and readme.md. This confirms the starter cloned correctly and everything is in place. Now open the project in your editor. If you are using VS Code, run code. Or open it from your editor's file picker if you prefer. Either way, get the project open so we can take a look at what is inside before we start the server. Take a quick look at the folder structure in the Explorer panel on the left. Inside SRC, you will see app, components, lib, and types. This is a standard Next.js App Router project. The auth flow is already wired up. The UI shell is already built. Our job today is everything that goes on top of it. Let us quickly open a few key files so you understand the starting point. Open src/app/layout.tsx. This is the root layout. It loads the Sign and JetBrains monofonts from Google and wraps the entire app. Nothing to change here. Open src/app/page.tsx. This is the landing page. It has a hero section with 3 buttons: preview candidate, preview recruiter, and sign in. This is just a shell. The real work happens inside the dashboard routes. Open src/app/candidate/dashboard/page.tsx. This is the candidate dashboard. Right now, it is running on mock data. You can see mock_sessions and mock_attempts defined at the top. The component renders interview summaries and recent submission stats. By the end of today, this will all be live data. Open src/app/recruiter/dashboard/page.tsx. Same thing on the recruiter side. Mock data for sessions and a live activity feed. The recruiter dashboard preview component renders KPIs, active coding sessions, and candidate activity. All of this will be real by the time we are done. Now open src/components/starter/starter-authguard.tsx. This is the higher order component that protects routes. It uses insforge.auth.getCurrentUser inside a useEffect. If no user session is found, It clears the local auth hint and redirects back to the login page. This is already working. We do not need to touch it. Open src/lib/insforge.ts. This initializes the insforge SDK client. It imports create client from @insforge/SDK and exports an instance called insforge, initialized with a base URL and an anonymous key pulled from environment variables. And finally, open src/types/session-user.ts. This defines the session user interface with 4 fields: ID, email, full_name, and avatar_URL. This is the shape of the user object we will be working with throughout the build. Now let us get the environment set up. In the terminal, run cp.env.example, env.local. This copies the example environment file into the local version that Next.js will actually read. Open .env.local in the editor. You will see 3 variables: next_public_insforge_URL, which is your insforge project URL, next_public_insforge_anon_key, which is your anonymous JWT key, and next_public_app_URL, which should be set to http://localhost:3000 for local development. Fill in your insforge URL and anon key from your insforge project dashboard. Run the dev server. npm run dev. Next.js starts up and you should see it listening on http://localhost:3000. Switch to the browser and navigate to localhost 3000. The Interview Ninja landing page loads. Click Preview Candidate. The browser takes you to /candidate/dashboard and you can see the Hey Alex dashboard with the mock interview data. Click Recruiter in the top nav. You land on the Hey Morgan Recruiter view with the KPI cards and the activity feed. Now click Sign in the top right. The login page loads with the Continue with Google button. If your insforge credentials are correctly set in .env.local, clicking that button will initiate the Google OAuth flow. If you see a network error here, it means the environment variables are not set correctly yet. In the next step, we start building out the real data layer and connecting everything to a live backend. Let us keep going. Before we start building, let me quickly show you the platform powering the backend of this entire project. Open a new tab in the browser and navigate to insforge.dev. This is insforge. The headline says it all. The backend built for agentic development. You can see the CLI command right there on the landing page. But what I want you to notice is what insforge actually gives you out of the box. Scroll down and you can see the full feature list. Postgres database for structured data, cloud storage for files and images, authentication with OAuth and link-based logins, serverless functions, real-time data sync, AI integration for connecting language models, and deployment. That is a complete back-end stack. No stitching together 5 different services. It is all in one place. Keep scrolling and there is a performance comparison section. insforge benchmarks at 1.6 times faster, 30% fewer tokens, and 1.7 times higher accuracy compared to alternatives. And at the bottom of the page, you can see the scale it is running at. Over 18,000 total projects and over 173,000 megabytes of database size. This is what we are building on today. Now let us look at how it works. Switch to VS Code. The project is already open. Let us orient ourselves before we start writing any code. Open .env.local. You can see 2 key variables already set. Next_public_insforge_URL is pointing to your insforge app engine URL. Next_public_insforge_anon_key is your anonymous JWT key. These 2 values are what the SDK uses to connect to your backend. Make sure both are filled in with your actual project values from the InsForge dashboard. Now open src/app/auth/login/page.tsx. This is the login page. Hover over the use effect block and you can see the TypeScript signature for get current user. It returns a promise that resolves to either a user schema or an InsForge error. The auth flow is already wired. We do not need to rebuild it. We just need to make sure the SDK client is initialized correctly and pointing at the right project. Before we write that initialization, let us spend a minute in the documentation so you understand exactly what we are doing. Go back to the browser and navigate to docs.insforge.dev. Land on the introduction page, then go to core concepts, then authentication architecture. Read through this section. The technology stack uses JWT with HS256, HMAC-SHA256, and stateless JWT tokens. The authentication flow covers email verification and link-based logins. There is also session recovery built in, and the JWT token structure is documented, so you know exactly what fields are available on the decoded token. Scroll down to SDK references, and you can see InsForge supports TypeScript, Swift, Kotlin, and Flutter. We are on TypeScript today. Now navigate to core concepts, then database architecture. This is worth knowing. InsForge uses PostgreSQL 15 with Postgres 12. The way it works is you define your schema, Postgres auto-generates the API layer, and queries are translated transparently. The data types table shows you how InsForge types map to PostgreSQL types and JSON types. Text, integer, float, boolean all behave exactly as you would expect. Navigate to core concepts, then storage architecture. InsForge uses an S3 compatible storage system. The upload flow, download flow, and security features including bucket policies and JWT authentication are all documented here. We will come back to storage when we build the file upload feature. Now navigate to getting started, then quick start. 2 steps: create your project and install the InsForge CLI. Then navigate to TypeScript, then TypeScript SDK. Find the installation command under the installation header. Highlight it and copy it. npm install at insforge/sdk at latest. Switch back to the VS Code terminal. Paste the command and run it. npm install at insforge/sdk at latest. The output confirms it's installed correctly. 1 package added, 377 packages audited. Now go back to the browser documentation one more time and find the quick start code block. It shows exactly how to initialize the client, import create client from @insforge/sdk const insforge equals create client with base URL set to your app URL and anon key set to your anonymous key. That is the pattern. Now let us implement it properly using environment variables. Open src/lib/insforge.ts. This is where the SDK client lives. Write the following: import create client from @insforge/sdk. Then pull the 2 values from environment variables, const base URL equals process.env.next _public _insforge _URL with a fallback to an empty string. Const anon key equals process.env.next _public _insforge _anon _key with a fallback to an empty string. Then export the client. Export const insforge equals create client with base URL and anon key passed in. That is the entire file. 5 lines. But this single export is what every other file in this project imports when it needs to talk to the backend. The database, authentication, storage, and real-time features all flow through this one client instance. Save the file, The SDK is initialized. The client is pointing at your InsForge project. We are ready to start building. Alright, the SDK is installed and the client file is ready. Now we need to create the actual InsForge project on the dashboard and connect it to our local code base. Let us do that now. Go back to the browser. We are on the InsForge documentation page. Navigate to insforge.dev. In the top right corner, hover over the profile icon next to the dashboard button and click dashboard from the drop-down. The organizations page loads. You can see one existing organization called Personal Org on the free tier with one project already inside it. Click that organization card. Inside the organization, you will see the existing project. We do not want to use that one. Click the plus new project button on the right side of the screen. A create project modal appears over a map background. Type Interview Ninja into the project name field. The region defaults to US East North Virginia. Leave that as is and click Create Project. A loading screen appears with the InsForge logo and the message, Building Project. This may take 2 to 3 minutes. Let it run. Do not close the tab. When the project dashboard finishes loading, a Connect Project modal automatically pops up. This is exactly what we need. Step 1 is Link Project. It gives you a terminal command that looks like this: npx at insforge/clilink --project-id followed by your project ID. Copy that command. We are going to run it in VS Code right now. Switch to VS Code. The insforge.ts file is open in the editor. You can see the client initialization we wrote earlier. Open the integrated terminal at the bottom and paste the command you just copied. Hit enter. The terminal asks, need to install the following packages at insforge/CLI. OK to proceed. Type Y and press enter. The CLI package downloads and installs. You will see a few npm warning messages about unsupported engines for post-hoc node. Ignore those. They do not affect functionality. Watch the terminal output. It runs through several steps. Installing InsForge agent skills. InsForge agent skills installed. Installing find skills installed. And then linked to Project Interview Ninja. Switch back to the browser. In the top center of the screen, you should see a green toast notification. Successfully established connection with the agent. And in the dashboard getting started area, the agent status has changed from not connected to a green connected. You can see a visualization showing the agent box connected to the database box with one MCP call. The link is live. Now click the connect button in the top right corner of the dashboard to reopen the connect project modal. This time we want step 2, verify connection. Copy the prompt text from that step. It reads, I am using InsForge as my backend platform. Read the current directory, make sure InsForge skills are installed, and use InsForge CLI for backend tasks. Switch back to VS Code and open the Composer or Chat interface in your editor. Paste that prompt and send it. The AI agent starts processing. It reads the CLI skill and project configuration, explores the project structure, identifies the components, lib and src directories, and reads package.json to confirm the InsForge SDK is listed as a dependency. Then it checks .env.local and notices the placeholder values for next_public_insforge_URL and next_public_insforge_anon_key. These need to be real values before the app can talk to the backend. The agent runs the InsForge CLI skill to fetch the full backend metadata for the linked project. It retrieves the actual anon key from the project secrets automatically. Then it applies the fix directly to .env.local. You can see the diff in the editor. Next_public_insforge_URL is updated from the placeholder to your real InsForge app engine URL. Next_public_insforge_anon_key is updated from the placeholder to the full JWT string. The agent then summarizes what it did, verified the project link, retrieved the URL and anon key, and updated the environment variables. You do not have to do any of that manually. The CLI and the agent handle it. Review the updated .env.local file to confirm both values are now populated correctly. The client is connected to a live backend. Before we move on, let us take a quick look around the InsForge dashboard so you know what is available. Go back to the browser and close the Connect project modal. In the left sidebar, click Authentication. The users list is empty for now. That makes sense. Nobody has signed in yet. Click Auth Methods under Authentication. You can see 3 providers configured: email password, Google OAuth, and GitHub OAuth. Click the 3-dot menu next to Google OAuth and select Edit. The modal shows that shared keys are enabled for development. That is fine for now. Close the modal. Click Database in the sidebar. No tables yet. You can see template options like CRM, AI chatbot, e-commerce, Reddit clone, Instagram clone, and more. We are not using a template. We will build our own schema from scratch. Click SQL Editor. A query tab opens with a sample select statement. No results because there are no tables yet. We will come back here once we start defining our schema. Click Storage. The buckets list is empty. We will create a bucket later when we build the file upload feature. Click the settings gear icon at the very bottom of the sidebar. Project settings shows your project name as Interview Ninja, the project URL, the masked API key, and the version. Everything looks correct. The InsForge project is created. The local code base is linked. The environment variables are populated with real values. The AI agent is connected and verified. We are fully set up. In the next step, we start building the database schema and wiring up the real data layer. Let us keep going. Alright, the project is linked, the environment variables are set, and the dev server is running. Now we need to build the database schema. This is the foundation everything else sits on. Get this right and the rest of the build moves fast. Let us open the schema.sql file. The first thing at the top is the UID extension. This enables UUID generation inside PostgreSQL, so every row gets a unique identifier automatically. Run that first before anything else. Below that, we define 2 enums. The first is user_role with 2 values, candidate and recruiter. Every user in this system has one of these 2 roles, and that determines what they can see and do inside the app. The second enum is difficulty with 3 values, easy, medium, and hard. This is used on the questions table. Now the tables. The users table is the foundation. It has 6 fields. ID is a UUID that defaults to UUID_generate_v4. Email is a unique text field. Full underscore name is text. Avatar underscore URL is text. Role uses the user underscore role enum we just defined and defaults to candidate. And created underscore at is a timestamp that defaults to now. Every person who signs in through Google OAuth gets a row in this table. The row field is what splits the app into 2 experiences, the candidate dashboard and the recruiter dashboard. The interview underscore sessions table is what recruiters create when they set up a new interview. It has an ID, a recruiter underscore ID that references the user's table, a title, a description, an active boolean that defaults to true, and a created underscore at timestamp. The questions table belongs to a session. Each question has an ID, a session underscore ID that references interview underscore sessions, a prompt field for the actual question text, a difficulty using our enum, an expected underscore concepts field for what a good answer should cover, and an order underscore index so questions display in the right sequence. The candidate underscore attempts table is the most important one for tracking performance. It records every time a candidate submits an answer to a question. It has a candidate underscore ID referencing users, a question underscore ID referencing questions, a code underscore submitted field for the actual code they wrote, a language field for the programming language, a score field, and a feedback field for AI-generated evaluation notes. Now, the row-level security policies. This is the part that makes the app actually secure. For the users table, a user can only read and update their own row. You cannot fetch another user's profile. For interview underscore sessions, recruiters can only see sessions they created. They cannot see sessions belonging to other recruiters. For questions, access is tied to the session. If you have access to the session, you can see the questions inside it. Candidates can see questions in sessions they are participating in. For candidate underscore attempts, a candidate can only see their own attempts. A recruiter can see attempts submitted by candidates in their sessions. Nobody can see data that does not belong to them. This is not optional. Without these policies, any authenticated user could query any table and see all data. With them, the database enforces access control at the row level regardless of what the API receives. Now let us run this against the live database. Switch to the browser and open the InsForge dashboard for the Interview Ninja project. Navigate to the SQL Editor tab in the left sidebar. Paste the entire contents of schema.sql into the query editor. The script is around 156 lines. Make sure the full content is in there before you run it. Click the Run button. Watch the results pane. If everything goes correctly, you will see confirmation that each statement executed successfully. The tables will be created, the RLS policies will be applied, and the trigger function will be registered. If you hit an error that reads column ID of relation buckets does not exist, this is coming from line 137 in the schema. That line tries to insert directly into storage.buckets to create a code submissions bucket for file uploads. The issue is that the InsForge storage schema handles bucket creation differently than a direct SQL insert expects. Do not try to force this through the SQL editor. Instead, remove that storage insert line from your schema script entirely. Paste the cleaned version back into the SQL editor and run it again. Once the rest of the schema is created successfully, go to the storage section in the InsForge dashboard sidebar and create the code submissions bucket manually through the UI. Set it to private. That achieves exactly the same result without the schema conflict. Once the schema runs without errors, go to the database section in the InsForge sidebar. You should see all 4 tables listed: users, interview underscore sessions, questions, and candidate underscore attempts. Click on each one to confirm the columns are correct. The database is built, the schema is live, row level security is enforced. The trigger is ready. In the next step, we start connecting the front end to this data and building out the real candidate and recruiter experiences. Let us keep going. Now let us install the remaining dependencies. Open the integrated terminal and run npm install at Monaco editor /react at Anthropic AI /SDK date fns. Monaco editor is the code editor component we will embed in the candidate interview view. The Anthropic SDK is what powers the AI feedback engine that evaluates candidate answers, and date.fns handles all the date formatting throughout the app. The installation will finish in a few seconds. You may see a note about moderate severity vulnerabilities. Acknowledge it and move on. It does not affect what we are building today. Now, the TypeScript types. This is important. Get this right and every component in the app benefits from full type safety all the way down to the database row level. In the File Explorer, Navigate to src/types. Create a new file called database.ts. Open the file. We are going to build this out section by section. Start with the enums. These mirror exactly what we defined in the SQL schema. Export type user role equals candidate or recruiter. Export type difficulty equals easy, medium, or hard. Now the feedback results interface. This is the shape of the AI-generated evaluation that gets stored in the feedback field on candidate attempts. Define it like this. Export interface feedback result with the following fields. Score is a number. Strengths is a string array. Weaknesses is a string array. Improvements is a string array. Summary is a string. Time underscore complexity is a string. Space underscore complexity is a string. This shape is what Anthropic returns after evaluating a candidate's code submission. Every field matters. Score drives the numeric display. Strengths, weaknesses, and improvements populate the feedback breakdown. Summary is the overall assessment, and the complexity fields give technical depth to the evaluation. Now the main database interface. This is the full typed representation of the database schema. Structure it like this. Export interface database with a public key containing a tables key. Inside tables, we define each table with row, insert, and update subtypes. For the users table, the row type has ID as string, email as string, full underscore name as string or null, avatar underscore URL as string or null, role as user role, and created underscore @, as string. For interview underscore sessions, the row type has ID as string, recruiter underscore ID as string, title as string, description as string or null, is underscore active as boolean, and created underscore @ as string. For questions, the row type has ID as string, session underscore ID as string, prompt as string, difficulty as difficulty, expected underscore concepts as a string array, and order underscore index as number. For candidate underscore attempts, the row type has ID as string, candidate underscore ID as string, question underscore ID as string, code underscore submitted as string or null, language as string or null, score as number or null, feedback typed as feedback result or null, and created underscore @ as string. Finally, add the helper type aliases at the bottom of the file. These give us clean import names everywhere in the app instead of repeating the long database bracket path each time. Export type user equals database public tables users row. Export type interview session equals database public tables interview underscore sessions row. Export type question equals database public tables questions row. Export type candidate attempt equals database public tables candidate underscore attempts row. Save the file. All TypeScript errors should resolve immediately. These 4 type aliases are what every component, hook, and API function in this app will import. When you fetch a user from the database, it comes back typed as user. When you create a session, the insert shape is enforced by the database interface. When Anthropic returns feedback, it gets stored as feedback result inside the candidate attempt row. The schema is live, the dependencies are installed, the types are defined, everything is in place. In the next step, we start building the actual candidate and recruiter experiences on top of this foundation. Let us keep going. Alright, the types are defined. Now we need a proper authentication guard component that does more than just check if a user is logged in. It also needs to verify that the user has the correct role before letting them into a protected route. A candidate should not be able to access the recruiter dashboard and vice versa. Let us build that now. Start by opening src/types/database.ts to remind yourself of the types we just defined. You can see user role as a union of candidate and recruiter. You can see difficulty as easy, medium, or hard. And you can see the full database interface with the user's table row type containing ID, email, full underscore name, avatar underscore URL, role, and created underscore art. We are going to use these throughout what we build next. In the File Explorer, expand src/components/starter. Open starter authguard.tsx. This is the existing auth guard from the starter kit. It handles 3 states: loading, unauth, and ready. We are going to use this as a template and build a proper version on top of it. Right-click on the src/components folder and create a new folder called auth. Inside that folder, create a new file called authguard.tsx. Select the entire contents of starter authguard.tsx. Copy everything and paste it into the new authguard.tsx file. This gives us the starting structure. Now update the props. The function signature currently just takes children. Add a second parameter, required role typed as candidate or recruiter. This is what callers will pass in to tell the guard which role is allowed on this particular route. Add an import for the user type from @types/database at the top of the file. Now update the internal state type. The current version is a simple string union. We need a discriminated union that carries data in the ready state. Define state as a union of 3 shapes. The first has status as the string loading. The second has status as the string unauth. The third has status as the string ready and includes a profile field typed as user. We also add a 4th shape with status as the string setup for users who have authenticated but not yet completed their profile. Now modify the run function inside the use effect. First call await insforge.auth.getCurrentUser. Check the result. If there is an error or the data.user is missing, trigger the logout flow. Call clear auth hint, set state to unauth, and call router.replace with /auth/login. Return early. If a user exists, extract the user ID. Const ID as user ID equals data.user. Now fetch the user profile from the database using the insforge client. Const data as profile equals await insforge.database.from_users.select*.eqid user ID dot may be single. Handle the case where no profile exists yet. If profile is falsy, call setState with status set to setup and return early. This sends users who authenticated but never completed onboarding to a setup flow. Now the role check. If profile.role does not equal the required role prop, redirect the user to their correct dashboard. If they are a recruiter trying to access a candidate route, redirect to /recruiter/dashboard. If they are a candidate trying to access a recruiter route, redirect to /candidate/dashboard. This enforces role-based access control at the component level. If the user is authenticated, has a profile, and the role matches, update the state to ready. Set state with status set to the string ready and profile set to profile cast as user. Now update the JSX render block. Check state.status. If it equals loading, render a full screen div with a spinner and the text restoring session. Keep this minimal. Users should see it for less than a second in most cases. If status equals unauth or setup, return null. The redirects inside use effect are already handling navigation, so there is nothing to render. If status equals ready, render the application layout. Pass the profile from state to the sidebar component. Starter sidebar with user set to state.profile. The component is now fully type safe. Save the file. Let us quickly review what this component does end to end. When a protected page mounts, AuthGuard shows a loading state while it checks the session. If no session exists, it redirects to login. If a session exists but no profile, it redirects to setup. If a profile exists but the role is wrong, it redirects to the correct dashboard. Only when all three checks pass does it render the actual page content with the user profile available to every child component. Every protected route in this app will wrap its content in this component with the appropriate required role prop. That is one component handling authentication, profile existence, and role-based access control in a single clean package. In the next step, we start building the recruiter and candidate dashboard experiences on top of this guard. Let us keep going. Alright, the auth guard is done. Now we need a sidebar that knows who is logged in and renders the correct navigation for their role. A candidate sees candidate routes, a recruiter sees recruiter routes, and we are going to add a role switcher button for development, so we can toggle between the two views without creating separate accounts. Let us build it. Start by opening src/components/starter/starter sidebar.tsx. This is the template sidebar from the starter kit. It has a static nav array with just two items, dashboard and settings. We are going to use this as a base and build something much more capable on top of it. In the File Explorer, navigate to src/components/UI. Right-click and create a new file called sidebar.tsx. Go back to starter sidebar.tsx. Select the entire file content, copy everything, and paste it into the new sidebar.tsx. Now we refactor. First, rename the component function from starter sidebar to sidebar everywhere in the file. Now define two interfaces at the top of the file. The first is nav item. It has three fields: href as string, label as string, and icon as react.element type. Use element type, not React node here. Element type allows us to pass lucid icon components as values and render them dynamically inside the map function. Now build the candidate navigation array. Const candidate nav typed as navitem array. It has four items. The first item has href set to /candidate/dashboard, label set to dashboard, and icon set to layout dashboard. The second has href set to /candidate/sessions, label set to sessions, and icon set to folder open. The fourth has href set to /candidate/history, label set to history, and icon set to history. Now build the recruiter navigation array. Const recruiter nav typed as navitem array. It has three items. The first has href set to /recruiter/dashboard, label set to dashboard, and icon set to layout dashboard. The second has href set to /recruiter/sessions, label set to sessions, and icon set to folder open. The third has href set to /recruiter/candidates, label set to candidates, and icon set to user icon. Now write the switch role helper function inside the component. Async function, switch role. First determine the new role, then update the database. Await insforge.database.fromUsers.update with role set to new role.eqid user.id. Then navigate, call router.refresh to update server components, then router.push to the appropriate dashboard based on new role. If new role equals candidate, push to /candidate/dashboard. Otherwise, push to /recruiter/dashboard. This function is primarily for development. It lets you test both sides of the app without maintaining two separate accounts. In production, you would remove it or gate it behind an admin check, so the wiring is already in place. In the next step, we start building the actual recruiter and candidate dashboard pages. Let us keep going. Alright, the auth guard component is built and the sidebar is role aware. Now we need to actually wire them into the routing system. In Next.js App Router, the way you protect an entire section of your app is through layout files. We are going to create one layout for the candidate portal and one for the recruiter portal. Each layout wraps its route in the auth guard with the correct required role. 2 files, about 8 lines each, and every route in those directories is protected. Let us do it. In the File Explorer, navigate to src/app/candidate. Right-click the candidate folder and create a new file called layout.tsx. Open the empty file and write the following from scratch. Import authguard from @/components/auth/authguard. Then export the default function. Name it candidate layout. It takes one prop, children typed as react.react node. In the return block, wrap children inside the authguard component. Set the required role prop to the string candidate. That is the entire file. 5 lines of actual code. But what those 5 lines do is significant. Every single page inside the candidate folder, every route, every subroute now requires the user to be authenticated and have the candidate role before it renders. If they are not logged in, authguard sends them to the login page. If they are logged in but have the recruiter role, authguard sends them to the recruiter dashboard. Only verified candidates get through. Now the recruiter layout. Navigate to src/app/recruiter. Right-click the recruiter folder and create a new file called layout.tsx. Open it. Highlight the entire content of the candidate layout file, copy it and paste it here. Make 2 changes. Rename the function from candidate layout to recruiter layout. Change the required role prop from the string candidate to the string recruiter. Save the file. That is it. The recruiter portal now has the same protection layer as the candidate portal. Unauthenticated users get redirected to login. Authenticated users with the wrong role get redirected to their own dashboard. Only verified recruiters see recruiter routes. Now let us test that this actually works. Switch to the browser and navigate to localhost 3000. The landing page loads normally. Now type localhost 3000/candidate/dashboard directly into the address bar and hit enter. Watch what happens. The screen briefly shows restoring session ... That is the authguard loading state running its checks. Because we are not logged in, there is no valid session. The authguard catches this, clears the auth hint, and redirects. The browser lands on localhost 3000/auth/login. The sign-in page appears with the continue with Google button. The guard is working correctly. Direct URL access to protected routes is blocked. The routing protection is live. 2 layout files, 8 lines of code combined, and the entire candidate and recruiter sections of the app are now behind authentication and role verification. Every new page you add under either folder inherits this protection automatically. You never have to think about it again. In the next step, we start building the actual dashboard content for both roles. Let us keep going. Alright, the routing protection is in place. Now we start replacing mock data with real data. The candidate dashboard currently shows hard-coded sessions and attempts. By the end of this step, it will be pulling live data from the InsForge database for the actual logged-in user. Let us do that now. Open src/app/candidate/dashboard/page.tsx. The first thing you will notice is mock_sessions and mock_attempts defined as constants near the top of the file. Hover over them. These are static arrays. Nothing about them is connected to a real user or a real database. We are replacing all of this. At the very top of the file, on line 1, type use client. This converts the component from a server component to a client component. We need this because we are going to use useEffect and useState for client-side data fetching. Without the useClient directive, React hooks are not available. Now add the React imports. On a new line near the top, add import useEffect. useState from React. The editor should autocomplete this. Accept the suggestion. Now write the useEffect hook directly after the state declarations. useEffect with an empty dependency array, so it only runs on mount. Now fetch the profile and the data we need. First the profile. Const data as profile equals await insforge dot database dot from users dot select star dot eqid user id dot maybe single. Then use promise dot all to fetch sessions and attempts at the same time, so we are not waiting for them sequentially. Const sessions data and attempts data equals await promise dot all with two queries inside. The first query, insforge dot database dot from interview underscore sessions dot select star dot eq is underscore active true dot order created underscore at with ascending false dot limit 5. The second query, insforge dot database dot from candidate underscore attempts dot select star and interview underscore sessions title dot eq candidate underscore id user id dot order submitted underscore at with ascending false dot limit 5. Notice the second query uses a join to pull the session title alongside each attempt. This is what lets us display the session name next to each submission in the history list. After both queries resolve, check the cancelled flag before setting any state. If cancelled, return. Update the AVG score calculation. To use the dynamic attempts state, const AVG score equals attempts dot length greater than 0. Question mark attempts dot reduce summing. Each attempt dot score divided by attempts dot length dot to fixed 1 colon null. Now update the JSX. This is where the dashboard visually connects to real data. The greeting line, change it to hey, then profile dot full underscore name dot split space bracket 0 with a fallback to the string there followed by an exclamation mark. This shows the user's first name if available. The sessions KPI card, replace the hard-coded number with total sessions. The submissions KPI card, replace it with attempts.length. The average score KPI card, replace it with AVG score with a fallback display for when no attempts exist yet. The sessions list, replace the map over mock underscore sessions with a map over the sessions array. Use session.id as the key. The attempts history list, replace the map over mock underscore attempts with a map over attempts. Use attempt.id as the key. For the session title, use attempt.interview underscore sessions dot title if the join data is available. Once the session issue is resolved and a user is fully authenticated with the candidate role, the dashboard will load the real profile name, the real session count, the real submission history, and the real average score from the database. In the next step, we fix the authentication callback flow and get a clean end-to-end login working. Let us keep going. Alright, the candidate dashboard is pulling live data. Now we need to build the most important back-end feature in the entire app, the AI code evaluation endpoint. This is what runs when a candidate submits their code during an interview. It sends the code to Claude, gets back a structured evaluation with a score, strengths, weaknesses, and complexity analysis, saves it to the database, and returns it to the UI. Let us build it. In the File Explorer, right-click the src/app directory and create a new folder called API. Inside API, create another folder called Evaluate. Inside Evaluate, create a new file called root.ts. Open the empty file. We are building a post handler here. Start with the imports at the top of the file. Import next response and next request from next/server. Import Anthropic from @Anthropic AI /SDK. Import create client from @insforge/SDK. Import the feedback result type from @types/database. Now set up the insforge client configuration. Pull the base URL and a non-key from environment variables. Const insforge base URL equals process.env.next_public_insforge_URL with a fallback to an empty string. Const insforge anon key equals process.env.next_public_insforge_anon_key with a fallback to an empty string. Define a helper function called createInsforgeClient that takes an access token as a string and returns a Prisma client instance initialized with the base URL, anon key, and access token. This is how we make authenticated database calls from the API route using the user's own token. Now define the evaluate request interface. This describes the shape of the request body, question ID as string, session ID as string, candidate ID as string, code as string, language as string, prompt as string, expected concepts as an optional string array. Now, two utility functions. The first is sleep. It takes milliseconds as a number and returns a promise that resolves after that timeout. We use this for retry backoff. The second is retryable error. It takes an unknown error and returns a boolean. It checks if the error is a 429 rate limit or a 529 overloaded response from Anthropic, or if the error message contains the strings overloaded or rate_limit. This tells us whether it is worth retrying or whether we should fail fast. Now the fallback feedback function. Name it build fallback feedback. It takes code and expected concepts as parameters and returns a feedback result. This runs when Claude is unavailable after all retries are exhausted. It calculates a basic heuristic score starting at 8. It checks the line count of the submitted code. If the code has more than 6 lines, it adds a point for completeness. It checks whether the code contains keywords from the expected concepts array and adjusts the score accordingly. It returns a feedback result with hard-coded strings in the summary field explaining that the AI evaluation is temporarily unavailable, and basic strengths and improvements derived from the line count and keyword matches. This is not a replacement for real AI evaluation. It is a safety net that ensures the candidate always gets some form of feedback even when the API is having issues. Now the Claude wrapper function. Name it call Claude with retry. It takes 3 parameters: an Anthropic client instance, an evaluation prompt string, and a max attempts number defaulting to 4. Inside, use a for loop that runs up to max attempts times. On each attempt, call anthropic.messages.create with the model set to Claude 3 Opus 2002-4229, max tokens set to 1000, and the evaluation prompt as the user message content. If the call succeeds, extract the text from the response, pass it as JSON, and return it cast as feedback result. If the call fails, check its retryable error. If it is retryable, calculate an exponential backoff delay using math.pow of 2 and the attempt index, multiply by 1000 milliseconds, and await the sleep function with that delay. Then continue to the next attempt. If the error is not retryable, throw immediately. No point waiting for more retries on a permanent failure. Now the main post handler. Pass the request body and extract all the fields from the evaluate request shape. Validate that question ID, session ID, and candidate ID are all present. If any are missing, return a 400 bad request with a clear error message. Check that Anthropic_API_ key exists in the environment variables. If not, we will still run but using the fallback. Extract the bearer token from the authorization header. This is the user's InsForge access token used to make authenticated database calls on their behalf. Build the evaluation prompt. This is the instruction set you send to Claude. Tell Claude it is acting as a senior technical interviewer. Give it the question prompt, the candidate's code, the programming language, and the list of expected concepts. Provide a scoring rubric from 0 to 10. 0 to 3 for non-functional or completely off-topic code. 4 to 6 for functional code with issues. 7 to 8 for solid implementations. 9 to 10 for exceptional work. Instruct Claude to return only a JSON object with no extra text. The schema must include score as a number, summary as a string, strengths as a string array, improvements as a string array, weaknesses as a string array, time underscore complexity as a string, and space underscore complexity as a string. Strict JSON output is critical here. The call Claude with retry function passes the response directly. Any markdown, explanation, or extra text outside the JSON will break the pass. Now call Claude with retry inside the try catch block. If it succeeds, store the result in a feedback variable and set used fallback to false. If it throws, log a warning, set used fallback to true, and call build fallback feedback with the submitted code and expected concepts. Now persist the result to the database. Create an InsForge client using the user's access token. Construct a storage path for the raw code file, something like candidate/candidate ID/question, id.ts or .pi depending on the language. Upload the code as a text file to InsForge storage. Check whether an attempt already exists. For this candidate ID and question ID combination, using a select query with maybe single. If a row exists, call .update with the new score, feedback, code, language, and storage path. If no row exists, call .insert with all the same fields plus the candidate ID and question ID. If the database operation fails, return a 500 error, but still include the feedback object in the response body. The UI can display the evaluation even if the database write failed. The candidate should not be left with nothing just because a database call had a transient issue. If everything succeeds, return a 200 response with the feedback, the score, and a used fallback flag so the UI can optionally show a notice when the fallback kicked in. Every piece has a clear responsibility. Save the file. Now quickly open src/app/auth/login/page.tsx. This is the login page. This is the entry point for all user authentication. We want to make sure the flow from Google OAuth through to the dashboard is clean before we test the full evaluation pipeline end to end. In the next step, we fix the auth callback flow and then test a complete candidate session from sign-in through code submission and AI evaluation. Now open .env.local. We need to add the Anthropic API key, navigate to a new line at the bottom of the file, and type Anthropic_API_key equals, leave the value empty for now. We are going to get the real key from the Anthropic console. Switch to the browser. Open a new tab and search for Claude API key. Click the link to platform.anthropic.com. The API keys page loads. Navigate to the API keys section in the left sidebar if it does not open directly. Then click the Create Key button. A modal appears asking you to name the key. Type Interview Ninja into the name field and click Create. The next modal shows your new API key starting with skent API03, followed by a long string. This key is only shown once. Click the Copy Key button immediately to copy it to your clipboard before closing this modal. Once you have it copied, close the modal. Switch back to VS Code, open .env.local. Find the Anthropic _API_ key line you added. Highlight the empty value and paste the key you just copied. The final line should read Anthropic _API_ key equals your full key, starting with skant API03. Save the file. One important note about the key you just created. The Anthropic console showed it to you once, and now it is gone. If you lose this value from your .env.local file, you will need to generate a new one. Never commit this file to Git. It should already be in your .git ignore from the starter project, but double check. The key gives full API access to your Anthropic account, and any requests made with it are billed to you. Also, restart your development server after adding the new environment variable. Next.js reads environment variables at startup. If the server is already running, it will not pick up the new Anthropic _API_ key value until you restart. Stop the server with Ctrl+C in the terminal and run npm run dev again. With the key in place, the evaluate route can now call Claude. The flow is candidate submits code, the dashboard posts to /API/evaluate with the code and question context. The route builds the evaluation prompt, calls Claude with retry logic, gets back a scored JSON response, saves it to the candidate _attempts table via InsForge, and returns the feedback to the UI. If Claude is unavailable or rate limited, the fallback function we wrote kicks in and the candidate still gets a response. The UI can check the used fallback flag in the response to show a notice if needed. Everything is now in place to test a full end-to-end evaluation. In the next step, we build the actual interview session UI, where candidates see questions and submit their code. Let us keep going. Alright, the evaluation API is wired up and the Anthropic key is in place. Now we need to build the page where candidates actually browse and select interview sessions. This is the entry point into the interview experience. A candidate lands here, sees all the active sessions available to them, picks one, and enters the interview. Let us build it. In the File Explorer, navigate to src/app/candidate. Right-click the candidate folder and create a new folder called Session. Inside that folder, create a new file called page.tsx. Open the empty file. At the very top, type use client. This is a client component because we are using useEffect and useState for data fetching. Without this directive, the hooks will not work. Now add the imports. We need several things: useEffect and useState from React, link from Next/link, arrow right from Lucid React, format distance to now from datefns, and insforge from @lib/insforge. Use the @/alias for all local imports rather than relative paths. This keeps the imports clean as the project grows. Define the component, export default function, sessions list page. Inside the function, declare 3 state variables. The first is loading. Const loading, set loading equals useState typed as boolean, initialized to true. The second is sessions. This one has an inline type for the array items. Const sessions, set sessions equals useState typed as an array of objects, each with ID as string, title as string, description as string, and created _at as string. Initialize it to an empty array. Now the useEffect hook. This runs once on mount and fetches all active sessions from the database. Declare a cancelled variable set to false at the top of the effect. This prevents state updates from running if the component unmounts before the fetch completes. Define an async function inside the effect and call it immediately. inside the async function, first get the current user. Await insforge.auth.getCurrentUser. We do not strictly need the user data for this query since sessions are visible to all authenticated candidates, but calling getCurrentUser first confirms the session is valid before hitting the database. Then query the sessions table. Const data equals await insforge.database. From interview underscore sessions dot select star dot eq is underscore active true dot order created underscore at with ascending set to false. If a recruiter deactivates a session, it disappears from this list automatically. After the query, check the cancelled flag. If not cancelled, call set sessions with data cast to the sessions array type and call set loading with false. Return a cleanup function from the effect that sets cancelled to true. Now the render block. Return the JSX. Wrap everything in the preview shell component with title set to the string sessions. If loading is true, render a simple loading state. A paragraph with the text loading sessions ... is fine for now. Otherwise, render the sessions grid. Inside the div, map over the sessions array. For each session, render a card div. Give it the session.id as the React key. Inside each card, render an h2 with the session.title. If a description exists, render a paragraph with session.description. Add a line clamp class to keep the card's uniform height if descriptions vary in length. Render the creation timestamp using format distance to now from date fns. Pass new date of session dot created underscore at and set add suffix to true. This gives you human readable output like 2 days ago. The candidate should be able to scan the list quickly and find what they need. Save the file. This page is now accessible at /candidate/session and is protected by the candidate layout we created earlier. Only authenticated users with the candidate role can reach it. The data is live from the database. Every time a recruiter creates a new active session, it appears here automatically. In the next step, we build the individual session page where the candidate actually sees the questions and writes their code. That is where the Monaco editor comes in and where the AI evaluation pipeline gets triggered. Let us keep going. Alright, this is the biggest build of the entire project. We are creating the live interview experience, the page where a candidate sees questions, writes code in a Monaco editor, and submits for AI evaluation. There are several files involved here, so let us go through them in order. Start in the File Explorer. Navigate to src/app/candidate/session. Right-click and create a new folder called bracket session ID bracket. This is a Next.js dynamic route. The session ID in brackets tells the router that this segment is a URL parameter. Inside the bracket session ID bracket folder, create a new file called page.tsx. Open it. This is the route entry point. It handles data fetching and passes everything down to the interview client component. Add use client at the top. Import use effect and use state from React. Import use params from next/navigation. Import insforge from @lib/insforge. Import the interview session, question, and candidate attempt types from @types/database. Import interview client from @components/candidate/interview client. This file does not exist yet. We will create it next. The import will show an error temporarily. Now, the main component. Navigate to src/components/candidate and create interview client.tsx. Set up the Monaco editor with a dynamic import so it never runs on the server. Const Monaco editor equals dynamic with a function that imports at Monaco editor/React. and an options object with SSR set to false. The loading fallback for the dynamic import should render a centered div with a loader to spinner and the animate spin class. Define two constants. The first is languages, an array of objects. Each object has a value string, a label string, and a numeric ID. Include JavaScript, TypeScript, Python, Java, C++, Go, and Rust. The second is starter_code, a record typed as string to string. Map each language value to a short boilerplate comment. For Python, use hash write your solution here, followed by a new line. For JavaScript, use / write your solution here, and so on for each language. This is what appears in the editor when a candidate first opens a question or switches languages. Define the interview client props interface with 4 fields. Session typed as interview session, questions typed as a question array, existing attempts typed as a candidate attempt array, and user ID typed as string. Inside the interview client component, set up the state variables. Current question index is a number initialized to 0. Language is a string initialized to JavaScript. Code is a record typed as string to string, initialized to an empty object. This stores the code the candidate has written for each question ID separately. Submitting is a boolean, initialized to false. Feedback is a record typed as string to any, initialized to an empty object. This stores the AI evaluation results for each question after submission. Scores is a record typed as string to number, initialized to an empty object. Then define 2 derived values. Current question equals questions, bracket current question index bracket. All answered is a boolean that checks if every question in the questions array has a corresponding entry in the feedback object. Use questions.every with a callback that checks if feedback bracket question.id bracket exists. Now the event handlers. Handle code change is a use callback that takes a value and updates the code record for the current question. ID set code with a spread of the previous code and a new entry using current question.id as the key. Handle language change takes a new language string. It updates the language state. If no code exists yet for the current question in the new language, it also resets the code for that question to the starter_code value for the new language. Handle submit is an async function. It runs when the candidate clicks submit. Set submitting to true inside a try block. Get the authenticated HTTP client from insforge.auth.getHTTP client. Call fetch with /API/evaluate method post the authorization header using the token from the HTTP client, content type as application/JSON, and a JSON body containing question ID as current, question ID, session ID as session, .id, candidate, ID as user ID, code as the current code for this question. Language, prompt as current question.prompt, and expected concepts as current question.expected_concepts. Pass the response JSON. Update feedback and scores state with the returned values. In the catch block, handle errors and set a submit error state. In the finally block, set submitting back to false. Now the JSX layout. The outer wrapper is a FlexCool H screen container with background color, hex 0E0E0E. The header section sits at the top. It shows the session title on the left. On the right, it renders a progress indicator, map over the questions array, and render a small dot for each. If the dot index equals current question index, it is the active dot and gets the accent color. If that question has a score, it gets the success color. Otherwise, it is muted. The main area uses a flex layout split into 2 panels with flex 1 to fill the remaining height. Then render the question prompt text in a scrollable container. The right panel is the code editor. Render the Monaco editor component with the following props. Value set to the current code for this question, defaulting to starter_code for the selected language. Language set to the language state. Theme set to VS Dark. OnChange set to handle code change. Options set to an object with minimap enabled false, font size 13, word wrap on, and padding top and bottom set to 16. Disable the button while submitting. If all answered is true, show a completion banner above the footer with a trophy icon and a congratulations message. Save both files. The session root, the badge component, and the interview client are all done. The flow end to end. A candidate navigates to /candidate/session, sees the list of active sessions, clicks one, lands on /candidate/session/the session ID, sees the first question with a difficulty badge, writes their code in the Monaco editor, clicks submit, the evaluate API route calls Claude, the result comes back, the feedback panel populates with the score and analysis, and the progress dot for that question changes color to indicate completion. Alright, the interview client component is built. Now we need the page that sits above it, fetches all the data, handles the different loading states, and passes everything down as props. This is the dynamic route page at /candidate/session/the session ID. Let us build it. Line 1, type use client. This is a client component because we are using hooks. Now add the imports. Use effect and use state from React. Use params from next/navigation. This gives us access to the URL parameter. Interview client from @components/candidate/interview client. Insforge from @lib/insforge. And the three database types, interview session, question, and candidate attempt from @types/database. Define the component, export default function, interview session page. Inside, call use params and extract the session ID, const params equals use params, const session ID equals params, dot session ID cast as string. Note the lowercase I in session ID. This must match the folder name, bracket session ID bracket exactly. Next.js lowercases dynamic segment names by default. Now define the state. This component has 4 distinct UI phases, and we model them as a discriminated union. Define state with useState, typed as a union of 4 object shapes. The first has status as the string loading. The second has status as the string not found. This covers the case where the session ID is invalid or the session has been deactivated. The third has status as the string empty. This covers the case where the session exists but has no questions assigned yet. The fourth has status as the string ready. This is the success state. It includes session typed as interview session, questions typed as a question array, attempts typed as a candidate attempt array, and user ID as a string. Initialize useState with an object where status is the string loading. Now the use effect. Inside the effect, declare a cancelled variable set to false. Define an async function and call it immediately. First, get the current user. Const data as auth data equals await insforge.auth.get current user. If auth data.user is falsy, set state to not found and return early. Extract the user ID, const user ID equals auth data.user.id. Now fetch the session. Query the interview underscore sessions table where ID equals session ID and is underscore active equals true. Use may be single. If the result is null or not found, set state to not found and return. Now fetch the questions for this session. Query the questions table where session underscore ID equals session ID ordered by order underscore index ascending. If the questions array is empty or has no items, set state to empty and return. Now fetch any existing attempts this candidate has made in this session. Query candidate underscore attempts, where candidate underscore ID equals user ID and question underscore ID is in the list of question IDs from the previous query. Use the in filter, passing an array of question IDs extracted from the question's result. After all three queries resolve, check the cancelled flag. If cancelled is true, return without setting state. Otherwise, call setState with status as the string ready and pass session, questions, attempts, and user ID into the object. Return a cleanup function that sets cancelled to true. Now the render block, check state.status. If it equals loading, return a full height centered div. Inside it, render a div with these classes: w5, h5 border 2 border of hex 2, 2 border t of hex 6 f4 f4, e rounded full animate spin. This matches the spinner style we used on the sessions list page. If it equals not found, return a centered paragraph that reads session not found. Use muted text styling. If it equals empty, return a centered paragraph that reads this session has no questions yet. Same muted styling. For the ready state, which is the default after the above checks, render the interview client component. Pass the following props: session set to state.session, question set to state.questions, existing attempts set to state.attempts, and user ID set to state.userid. Save the file. Let us review the complete flow one more time. A candidate navigates to /candidate/session/SAM-ID. The page mounts and immediately enters the loading state. The use effect fires, gets the current user, fetches the session, fetches the questions, fetches any existing attempts, and if everything is found, it transitions to the ready state. The interview client renders with all the data it needs. The candidate sees the first question, writes their code, submits, and the evaluation runs. If the session does not exist or is inactive, the candidate sees a clean not found message. If the session has no questions yet, they see an informative empty state. No crashes, no blank screens, no confusing behavior. This page is the bridge between the routing layer and the interview experience. It handles all the data concerns, so the interview client can focus purely on the UI and the evaluation logic. Now the recruiter side, creating sessions, managing questions, and viewing candidate results. We are not building that part in this video. That is your assignment. Everything you need is already in place. The database schema has the tables. The InsForge client is initialized. The auth guard and sidebar are already role aware. You have seen exactly how the candidate side was built. Apply the same patterns to the recruiter routes and you will have a complete platform. Drop your implementation in the comments. I want to see what you build. Alright, the build is done. Open a new tab in the browser and navigate to the InsForge dashboard for your Interview Ninja project. Go to the SQL editor. Open the seed.sql file from your project. It contains an insert into questions block covering multiple sessions. Paste it into the editor and click Run. When it succeeds, you should see SQL query executed successfully. Verify the data. Go to database, open the interview underscore sessions table. You should see 3 sessions: front-end engineering, data structures and algorithms, and back-end systems. All 3 share the same recruiter underscore ID and all 3 are active. Now test authentication. Open a new tab and navigate to localhost 3000. Click Get Started. The login page loads. Click Continue with Google. Select your account. The app redirects through /auth/callback. You will briefly see completing sign in, then restoring session. The auth guard is running its checks. Once the session is verified, it redirects to the appropriate dashboard based on your role. If you land on the recruiter dashboard, you can see 3 active sessions listed. The UI shows the correct session count. Now use the role switcher in the sidebar. Click switch to candidate. The URL changes to /candidate/dashboard. The greeting updates. The 3 sessions you seeded appear in the available interview section. Now enter an interview. Click on front-end engineering. The URL navigates to /candidate/session/the session ID. The left panel shows question 1 of 3. Implement a debounce function in JavaScript. The difficulty badge reads medium. The right panel is the Monaco editor with a boilerplate function. Let us write a solution. Rename the default function to debounce. Define a timeout variable in the outer scope. Inside the returned function, call clear timeout with timeout. Then set timeout to a new set timeout that calls fn after the delay. The implementation uses a closure correctly. The timeout variable persists between calls and clears on each new invocation, which is the core mechanic of debounce. Click Submit. The Submit button enters a loading state while the evaluation API runs. The request goes to /API/evaluate with the code, the question metadata, and the authorization token. The root calls Claude with the evaluation prompt and waits for the structured JSON response. After a few seconds, the feedback panel populates. Score: 6 out of 10. Strengths: correct use of closures, correct clearing of the timeout on repeated calls. Improvement areas: the solution does not forward arguments using .apply with this and arguments and does not preserve the this context. These are critical for a robust debounce implementation that can be used with any function signature. This is exactly the kind of specific, actionable feedback a technical interviewer would give, not a vague pass or fail. A real evaluation of what is correct and what is missing. Now verify the data persisted. Go back to /candidate/dashboard. The stats now show 1 submission and an average score. Click History. The list shows the front-end engineering submission with the score. Now go to the InsForge dashboard, open the database section, and check the candidate_attempts table. A new row is there with the candidate ID, the question ID, the score, the full feedback object as JSON, and the language. Now go to storage and open the code submissions bucket. You should see .javascript files. These are the raw code files uploaded as blobs during the evaluation. The file path follows the pattern we defined in the root. Candidate/the candidate ID/the question ID.javascript. The data is persisting end to end. Code goes in, Claude evaluates it, the score and feedback land in the database. The raw code is saved to storage, and the dashboard reflects the updates in real time. And that is Interview Ninja, fully built and deployed. We went from a blank terminal to a live AI-powered interview platform. Google OAuth through InsForge, a Monaco code editor in the browser, Claude evaluating submissions in real time, data persisting to PostgreSQL with row-level security, and the whole thing running live on Hostinger. If you built along with this video, drop your deployment link in the comments. I want to see what you shipped. The recruiter side is your assignment, session creation, question management, candidate results. Everything you need is already in the code base. Apply the same patterns and you will have a complete platform. If you found this useful, subscribe. More builds like this are coming and you do not want to miss them. Code is in the description. Hostinger link and the discount code ALBERTAI are down there too if you want to deploy your own version. See you in the next one. Today, we are building something massive. A full stack AI-powered career coach that generates 12-month roadmaps and gives you a personal mentor named Jake. Let's not waste any time and dive right into the walkthrough. When you first log into the app, you'll be asked to onboard by filling in details about your career path. This ensures the AI generates a plan tailored specifically for you. Once those details are in, we hit that Generate My 12-month plan button. This sends a request to the Gemini AI model to crunch your data. Within a few seconds, you get a detailed monthly breakdown. Each month contains a sub-detail or a focus area where you can keep track of your progress. We also have Jake, our AI career assistant. Jake uses the same Gemini AI to understand your career context and offer advice or answer follow-up questions. These are the core features, and there is so much more to cover. Stay tuned for this in-depth tutorial. Before we dive into the technical setup, I want to give a quick shout out to Hostinger for powering this tutorial. When it comes to hosting, reliability and performance are everything, and their VPS hosting is a total game changer for developers. Whether you are running a simple web app or a complex Docker containerized system like the one we are building today, Hostinger provides a seamless, high-performance environment with full root access and Ubuntu support. It is an incredibly affordable, all-in-one platform for managing your domains and servers. If you are ready to take your own projects professional, I have a special deal for you. Head over to Hostinger and use the coupon code ALBERTAI at checkout to get a significant discount on your hosting plan. It is the exact service I use to keep my applications running fast and 24/7. Now let's get into the system architecture for this project and set this up from scratch. Let's dive right in and break down the architecture for our modern full-stack application. This is the bird's eye view of how every piece of our puzzle fits together, from the user's click to the data sitting in our database. First, we start on the far left with the user layer. Here, the user interacts with the browser or client, sending out HTTP requests that hit our front end. Moving into the green box, we have our Next.js 16 app. This is the heart of our interface. Inside the app directory, we have our main page.tsx file. This is where we handle our state management. We have several key components here: the plan section, the onboarding card, the Jake chat panel, and our navbar and header. Under the hood in the front end, we are using a Clark provider inside layout.tsx to wrap our app in authentication. We also have a central app state that keeps track of the user profile, their plan, and the chat history. To keep things secure, we have a middleware.ts file sitting at the edge, intercepting requests to ensure only authorized users get through. Now, look at the flow to our external services in the orange box. When a user signs in or signs up, our app communicates with the Clark auth service. Clark sends back a user ID and a session JWT, which we then pass along to our backend. In that same external services box, we have the Google Gemini AI. This is the brain of the operation. It receives messages and context to generate Jake's replies, and it also handles generating those custom 12-month plans. Next, let's trace the lines to the backend APIs in the pink box. We have three main endpoints here. First is post/API/plan, which receives the plan JSON from Gemini. Then we have post/API/chat, which handles the back and forth reply text. Finally, there is a get and post/API/state endpoint. This one is crucial because it syncs our app state JSON with the rest of the system. Finally, on the far right, we hit the database layer. Our API routes connect through a library folder using the file mongodb.ts. This establishes the connection to our MongoDB Atlas instance. All that data ends up in the user_states collection, creating a persistent loop for our application. And that is the full flow. We have got a clean, scalable architecture ready for production. I hope this walkthrough gave you a clear picture of how these services talk to each other. Now, let's set up the project. Open up your favorite code editor. I am using Cursor AI on the left side, and on the right, I have the browser open so we can see what we are building in real time. Let's open a new tab and search for Next.js CN. On this website, we are going to copy the create project command. Now, back in the editor, let's open the terminal by hitting Ctrl+tilde. Paste that command and hit enter to install it. Just select the default options for all the prompts that come up. Once it is finished, you should see the message success, project initialization completed inside your terminal. On the left-hand side, you will see our new file structure. First, we have the source folder containing the app directory. Think of the app directory as the heart of your application. It handles all your routing and organizes your different pages. Inside that app directory, we have the layout.jsx file. This file acts as a wrapper for your entire application, allowing you to define UI elements like navbars or footers that stay the same across every page. Next to it is the page.jsx file. This is the actual unique content of your home route. It is what the user sees when they land on your main URL. We also have a lib folder containing a utils.js file. This folder is a dedicated spot for utility functions, reusable pieces of code that help with things like formatting dates or merging CSS classes. As we progress through this tutorial, we will explore more of these files in detail. Now let's get this project running. In the terminal, type cd followed by your project folder name, then type npm run dev and hit enter. This will start the local development server on localhost :3000. You can hold command and click that link to open it in a new tab. And there we go. We have the Next.js boilerplate code fired up and running on the right side of the screen. Now that we have our project initialized, it is time to handle the most important part of any modern app: authentication. We are going to use Clark, and if you have not heard of it, Clark is a complete user management solution that handles everything from sign-ins to security out of the box, so we do not have to build it from scratch. Let's head over to the Clark documentation. We already have Next.js set up, so we are jumping straight to step 2. Grab that installation command from the docs and paste it into your terminal. It is npm install at clerk/next.js. While that installs, let's tackle step 3, creating a middleware file. In your root directory, create a new file called middleware.t-s. This file is like a security guard for your app. It intercepts every request to check if a user is allowed to see a page. Now let's copy the middleware code from Clark and paste it in our middleware file. Now let's move to step 4. Open your layout.jsx file in the app directory. We need to wrap our entire application in the Clark provider so every component can access the user's auth state. Import Clark provider from @clark/next.js and wrap it around the body tags. Inside the body, right above the children props, we are going to add some UI. Let's add a header and a div. and inside we will import and place the sign in button and the user button from Clark. For the user button, let's add an appearance prop. We will set the elements object to target the user button avatar box and give it a width and height of 10 to make it look sharp. Next, let's clean up our home page. Open page.jsx and delete everything inside the return. Replace it with a simple paragraph that says "Hello World." At the top of the file, we need to add the useClient directive because we are using hooks. We will import useAuth from @clerk/Next.js along with useEffect and useState from React. Inside our component, let's destructure isLoaded and user ID from the useAuth hook. IsLoaded is a boolean that tells us if Clerk has finished checking the session, and user ID gives us the unique string for the logged in user. We will write a simple check. If not user ID, then return a div. Inside that div, let's add an anchor tag pointing to /signin, then a break tag, and another anchor tag pointing to /signup. Now we need to build the actual auth pages. Create a folder in the app directory called sign in. Inside that, create a special folder using double square brackets with 3 periods, square bracket, triple dot, sign-in, square bracket, square bracket. This is a catch-all route that Clerk needs. Inside that folder, create page.tsx. Let's write the sign-in page script. First, we import sign-in from @clerk/Next.js. We export default function sign-in page, and inside the return, we start with a large container div. We give it a flex column layout with a minimum height of the full screen, centering everything with item center and justify center. We add a nice background gradient from background via background to primary with a 3% opacity. Inside that, we create a wrapper for our header. We use an inline flex div for our logo, a rounded full border with the text Career Campus AI. Inside that logo box, we have a small primary colored square with the letters CC for our branding. Below the logo, we add an H1 that says "Welcome back" and a paragraph telling users to sign in to continue their journey. Now for the main event, we drop in the sign in component from Clark. We are going to customize it heavily using the appearance prop so it matches our app's aesthetic. We hide the default header title and subtitle, and we style the social buttons with a rounded LG border and a subtle hover effect. For the main submit button, we use a beautiful gradient from primary to emerald 500 with a shadow elk to make it pop. We even style the input field to have a primary colored ring when focused. Finally, at the very bottom, we add a footer link that redirects users to the sign up page if they do not have an account. We are going to do the exact same thing for the sign up page. Duplicate that folder structure, but name it sign up with the triple dot sign-up catch-all route. The code is nearly identical. We export default function sign up page. We keep the same flex container and that gorgeous background gradient. We keep our Career Campus AI logo at the top, but change the H1 to say "Start your journey" and update the subtext. When we drop in the sign up component, we pass in the same custom appearance object, so the buttons and inputs look consistent. The only difference here is we add 3 specific props to the component. Routing equals path, path equals /sign-up, and sign in URL equals /sign-in. This ensures clerk knows exactly how to navigate between the two forms. At the bottom, we update the footer link to point back to the sign-in page. And that is it. We have a fully secure, beautiful authentication flow ready to go. Now that we have our authentication logic ready, we need to handle what the user actually sees if they are not logged in. We do not want to just show a blank screen. We want to give them a high-end entry point to the application. Now back to the page .tsx. First, we will type a simple check, if not user_ID. Then we open up our return statement. This logic tells the app that if we do not have a verified user session, we should render this landing section instead of the main dashboard. Now, let us start building the UI. We will type a div with a class name of flex, min-height screen, items-center, and justify-center. This ensures our login card is perfectly centered, both vertically and horizontally. We will also add a background gradient to bottom right, starting from background through background to primary /0.03. This adds a very subtle, professional hint of color in the corner. Inside that, let us add a wrapper div with a width-full and a max-width-MD to keep the card from getting too wide on large screens, and we will add space-y-6 to keep our elements spaced out nicely. Next, we will type out our branding badge. This is an inline flex div with a rounded full border. Inside, we add a small flex container for the logo icon. Give it a height and width of 8, rounded LG, and a primary background. We will type the letters capital C inside, which stands for Career Campus. Right next to that, we will add a span with font semi-bold and tracking tight, and type out Career Campus AI. Now, let us build the main card. We will type a div with rounded XL border and a card background with some padding and a shadow LG to make it lift off the page. Inside this card, we start with our typography. We will add an H2 with a font bold and a text 2XL. To make it look premium, we will use a gradient from foreground to foreground /70 and apply background clip text so the color fills the letters. We will type "Welcome to Career Campus AI." Alright, so now below the heading, let us add a paragraph with a leading relaxed and muted foreground color. We will type "Get personalized career guidance and insights to help you achieve your goals." Finally, we need our call to action buttons. We will add a div with flex column and a gap of 3. First, we will type an anchor tag pointing to /sign-in. For the styling, we will use a gradient from primary to emerald 500. This gives it that modern AI feel. Inside the tag, we will add a sparkles component with a height and width of 4, followed by the text "Sign in." Right below that, we will add our second anchor tag pointing to /sign-up. This one will have a background and a standard border to make it a secondary action. We will add a target icon and the text "Create account." We are also adding a hover effect with a shadow primary /30 to give the user that tactile feedback when they hover over it. And there we go. Now, Whenever an unauthenticated user hits our homepage, they are greeted with a beautiful professional entrance. We are making some impressive progress. Now that we have handled the gatekeeping with our authentication check, it is time to build out the actual dashboard experience for our logged in users. We are starting with the foundation of the homepage layout and a sleek, modern navbar. Inside the return statement of our homepage, we are going to start by typing out a div with a class name of flex, main-height screen, and flex-column. We will set the background to background, add some padding -x of 6 and padding -y of 6, and set the text color to foreground. To make sure this looks great on all devices, we add responsive padding. Next, we will add a wrapper div with m-x-auto, flex width-full, and a max width of 14-40 pixels. We will also add flex-1 and a gap of 6. This container keeps our entire layout centered and perfectly aligned as the screen gets wider. Now, I want us to quickly work on the navbar. Instead of cluttering our main page, we are going to stay organized. Let us create a new directory inside the parent folder structure called components. Inside that, we will create another folder called home, and finally a new file called sections.tsx. This file is going to be our main hub for all the homepage components. Let us start by defining the navigation bar. We will type a nav tag with a class name of rounded dash, x-l, border, and border-border. We will set the background to card with padding -x of 4 and padding -y of 3. We will keep the text -sm and add a subtle shadow -sm. For larger screens, we will bump that padding up slightly using sm:/px5 and sm:/py 3.5. Before we go any further, let us import this into the homepage. I am going to temporarily adjust our logic so that even when a user is not logged in, we can see what we are building. And there we have it. You can see that clean floating ring for the navbar showing up on the screen. Let us jump back into sections.tsx and keep working on that navbar content. Inside the nav tag, we will type a div with flex-wrap, items-center, and justify dash between with a gap of 3. This ensures our logo and menu items stay on opposite ends, but stack nicely if the screen gets too small. Inside that, we will create another flex container for the branding. We will type out a div with items-center and a gap of 3. Then we add our logo box. A flex container with a height and width of 8, rounded -LG, using the primary background color. Inside, we type capital C in a bold, small font. Right next to the logo, we will add a div to hold our text. First, a paragraph with text that says Career Compass AI. Underneath that, let us add a smaller paragraph with text, private, personalized, and powered by AI. This gives the app a very professional, high-tech feel right from the first glance. Now let us head back to the home page to see how it all ties together. We are moving fast. Now that our layout is ready, it is time to build the heart of the user experience, the onboarding form. This is where we collect all the data that our AI needs to build that custom roadmap. Let us jump into our sections file and start defining the onboarding card component. We will export a function called onboarding card, and inside the props, we are going to destructure onSubmit, is generating plan, and generation-step-test. We will define the type for onSubmit as a function that takes a user profile and returns a promise of void. Now, you might notice a red wavy underline under user profile. That is because we have not defined our types yet. To keep things clean, let us head over to the source/lib folder and create a new directory called career-type. Inside, we will create an index.ts file to manage all our project types. First, we will type export type task status and set it to a union of not-started, in progress, or complete. Then we define our task type with an ID, title, description, and a category like learning or networking. Next is the month plan type, which includes an index, a theme, a summary, and an array of those tasks we just defined. We also need a plan type, which is just an object containing an array of month plans. Now for the important one, export type user profile. This includes name, current role, years experience, desired role, and strings for time per week, constraints, and challenges. We will also add an app stage type to track if the user is in onboarding or viewing their plan. A chat message type for our AI assistant, Jake, and finally, an app state type to tie everything together. Alright, types are done. Let us head back to the onboarding card in our sections file. We will start by setting up some state. We will initialize all the fields like name and current role as empty strings. We also need a name input ref using use-ref to handle autofocus. We will add a use effect that runs once on mount, calling name input ref.current.focus. This is a small detail that makes the app feel much more professional. Next, we will create a variable called isValid, which simply checks if the required fields like name and desired role are not empty after being trimmed. Now, we will type our change handler. Const handle-change equals an arrow function, taking a field and a value, which calls set-form and spreads the previous state while updating just that one field. For the submission, we will type handle submit. It prevents the default form behavior, checks if the form is valid and that we are not already generating a plan, and then calls our onSubmit prop with the form data. Time for the UI. We will return a section with a rounded XL border and a card background. Inside, we will add a header div. On the left, we will place a target icon inside a primary colored box, and next to it, an H2 that says start with your career destination, followed by a short description. On the right side of the header, let us add a badge that says Step 1 using a sparkles icon. Now, we will type out the form tag, giving it a relative position and a 2-column grid layout for medium screens. Inside the form, we will add a loading overlay. This div only shows up if its generating plan is true. It uses backdrop --blur and animate -spin loader and displays the generation step text to keep the user engaged while the AI works its magic. Next, we build the inputs. For each field, like name, current role, and years of experience, we add a label with a specific icon and a styled input. Notice how we use background /50 and backdrop blur on the inputs. This gives them a glass morphism effect that looks incredible. We link each value to our form state and call handle change on every keystroke. For the challenges section at the bottom, we will use a text area with 3 rows and set call-span-2 so it takes up the full width. Now, let us import this onboarding card into our main homepage. We will provide some test props and a simple void function for onSubmit for now. If you look at the right side of the screen, there it is. Our onboarding form is looking sharp and ready for action. Now that the onboarding form is looking solid, we need to build the other half of our dashboard, our AI career assistant, Jake. But before we do that, let us quickly refactor the homepage to keep our layout precise. We are going to wrap everything inside one main div. This ensures our sidebars and main content align perfectly as we add more features. Now let us create the container for our chat interface. We will type an aside tag with a class name of flex, width full, and shrink 0. For larger screens, we will set the width to 420 pixels using LG:W bracket 420px bracket, and even wider at 460 pixels on extra large screens. We will also add some padding left on large screens to give it some separation from our main roadmap. Let us jump into our components file and build the actual chat panel. We will export a function called Jake Chat Panel. In the props, we are destructuring messages, input, on input change, on send, and is sending. This component needs to be very reactive, so we are passing everything it needs to communicate with our main state. First, we will type const scroll container ref equals use ref of type HTML div element or null. This is crucial for a chat app. We want the window to automatically scroll to the bottom whenever a new message arrives. We will add a use effect that watches the messages array, grabs the scroll element, and sets its scroll top to the scroll height. This keeps the latest advice from Jake always in view. Now for the UI, we will return a section with a height full and a card background. We will use overflow, hidden and rounded XL to keep it looking like a contained widget. Inside, we will add a header with a rounded full primary icon containing the letter capital J. Next to it, we will add an H2 for Jake, your career assistant, and a small caption explaining what the user can ask him. Below the header, we will type a div that acts as the chat box. We will give it a background /60 with a subtle border. Inside this box, we attach our scroll container ref and use the map function to loop through our messages. For each message, we check if msg dot from triple equals user. If it is from the user, we use justify end to push it to the right. Otherwise, we use justify start to keep Jake's messages on the left. Finally, let us build the message input at the bottom. We will type a form and intercept the onSubmit to call our onSend function. Now, let us head back to the home page and import our Jake chat panel. We will pass in some boilerplate props for now, just so we can see the layout, and check it out on the right side of the screen. Jake is officially in the building. We do not have the API connected just yet, but the interface is ready for some AI brains. We are building out the core logic and the beautiful user interface for our AI career planner. We need a way to track where our user is in their journey and visually represent their progress. Let's jump right into the code. First, we will type out our state management. We are using the useState hook from React. We will define a constant, open bracket, state, set, state, close bracket, equals useState. We are passing in a type of app state, which we imported from our career types. And initializing it by calling a function named create-initial-state. This keeps our main component clean by moving the starting data logic elsewhere. Since we haven't defined that initializer yet, let's build it now. We type function create-initial-state, which returns an app state object. Inside the return, we set the stage to onboarding, set the profile and plan to null, and the selected month ID to null as well. We also initialize the chat array with a welcome message from Jake, our AI assistant, using date.now for the timestamp. This gives our users a warm welcome the moment they land on the app. Now, in our main JSX, we need to decide what the user sees. We will add a condition. Open curly brace, state.stage, triple equals, onboarding, or exclamation point, state.plan. This logic check says if we are still onboarding or if there is no plan generated yet, show the onboarding card. Otherwise, in our else clause, we will render the plan section. Let's move over to our new component file and create that plan section. We type export function, plan section, and we are going to destructure a lot of props here, like profile, plan, selected month, and several handler functions like on select month and on update task status. Inside the component, the first thing we do is create a constant called overall, which equals calculate plan progress, passing in our plan. This is going to give us that high-level bird's eye view of the entire 12-month journey. Let's define that helper function, calculate plan progress. It takes in a plan, and if there is no plan, we return 0 immediately. Now for the UI, we return a section tag with some spacing. Inside, we have a card that displays the journey title and a dynamic description. We use optional chaining on the profile. Now back on the home page, let's import the plan section and pass in our state as props to bring it all to life. Alright, let's get into it. We are about to build out the core of our application, starting with the AI and database logic. This is where the magic happens. First, we need to organize our file structure. Inside the app directory, we will create a new folder named lowercase API. Inside that API folder, let's create 3 more folders named chat, plan, and state. We are starting with the chat functionality. So let's go ahead and create a file named root.ts inside that chat folder. Now, before we write the code, we need access to the model. Let's head over to Google AI Studio in the browser to generate a new Gemini AI API key. Once you have that key, hop back into the code and open your .env file. We are going to add a new line here. Type uppercase Google _API _key followed by an equal sign and paste your key right there. Now, let's head back to our chat route file to build the AI functionality. On the right side of my screen, I have the Gemini AI documentation open. I will leave a link for that in the description so you can dive deeper into the details later. To get started, we need the official package. Let's open the terminal and type npm install at google/generative AI. And just like that, we are ready to start coding the logic. We have our folder set up, our API key secured, and our package installed. In the next step, we are going to initialize the model and handle our first prompt. It is time to bring our AI assistant to life. We are going to build the back-end logic first and then wire up the front end to make the chat interactive. Let's dive into the code. First, in our root.ts file, we need to bring in our tools. We will type import, open curly braces, Google Gen AI, close curly braces, from at google/Gen AI. Right below that, let's import next response from next/server so we can send data back to our front end. Now, we need to initialize the AI. We will type const AI equals new Google Gen AI and pass in an empty object for now since it will read our environment variable. Next, let's define our models by typing const chat models equals, and we will create an array containing Gemini 3 Flash preview and Gemini 2.5 Flash, followed by as const to keep the names fixed. Let's create our main function. We will type export async function post, taking in the request object. Inside, we will start a try-catch block to handle any errors gracefully. First, we extract our data by typing profile, plan, selected month ID, and messages, await request.json. Now for some logic, we need to find exactly where the user is in their journey. We will type const selected month equals plan, optional chain, months, optional chain, find, passing in a function to match the month ID to visualize progress. Let's write a small helper. We type const calculate progress equals an arrow function taken in tasks. Inside, if there are no tasks, we return 0. Otherwise, we filter the tasks where status equals complete and return the percentage using math.round. Using that helper, we will set const month progress by checking if the selected month exists, and if so, calling calculate progress on its tasks. For the big picture, we type const overall progress, where we reduce all the months in the plan to get one final percentage. Now, we need to give our AI a personality. We will define prompt using backticks. This is where we tell the AI, you are Jake, a supportive AI career assistant. We use template literals to inject the user's name, current role, and desired role. We also list out their time availability, constraints, and that overall progress percentage we just calculated. If they have a month selected, we loop through the tasks using map to show Jake exactly what needs to be done. To keep the conversation relevant, let's format the history. We combine everything into const full prompt, adding a final instruction to respond as Jake. Time to talk to the AI. We initialize let reply as an empty string. We will use a for loop to iterate through our chat models. Inside, we try to generate content by calling await ai.models.generate content. If we get a response, we trim the test and break out of the loop. If no models respond, we throw an error. At the very end of our try block, we return next-response.json containing the reply. If anything fails, our catch block logs the error and returns a 500 status code. Now, let's head back to the home page to connect the UI, where we have our Jake chat panel. Find the messages prop and set it to state.chat. For the input prop, we will simply pass input, which is a state we are about to create. Let's scroll up and define that state. We will need input and set input. Now, let's create the logic for sending messages. We type const handle send message equals an async arrow function. First, we call input.trim to clean up the text. If the input is empty or we are already sending, we simply return to prevent double messages. Next, we create the user's message object. We will type const user messages equals an object with a unique ID using date.now, the sender as user, and the content as our trimmed text. Now, we update our UI immediately by calling setState, spreading the previous state and adding our new message to the chat array. We also call set input to an empty string, and set is sending to true. Time to hit the API we just built. We type const res equals await fetch to /API/chat using the post method. In the body, we stringify our profile, plan, and the messages. We use map on the messages to only send the sender and the content to keep the payload light. If the response is not okay, we handle the fallback. We create a fallback message where Jake politely explains there is a connection issue and gives some manual advice. We then update our state with this fallback and stop the loading state. If the request succeeds, we pass the data by typing const data equals await res.json. We then extract the reply text or provide a default one if it is missing. Finally, we create a new message object for Jake and call set state to add Jake's response to the conversation. Now, let's test it out. Everything is looking amazing. The messages are flowing, and Jake is giving us that personalized career advice in real time. On the right-hand side, I have the MongoDB dashboard open. MongoDB is a NoSQL database, which is perfect for our project because it allows us to store flexible JSON-like documents without worrying about rigid table structures. I will provide a link in the description to help you set up your own cluster. But for now, let's walk through it. Once you sign up, create a new cluster and make sure you select the free tier on the far right. After naming your cluster and creating the deployment, a modal will pop up. Go ahead and create a username and password. Then choose drivers as your connection method. We will copy that connection string and head back to our code. Inside your .env file, we will create a variable called mongodb_URI and paste that string right there. Then let's add mongodb_db_name and set it to career_campus_AI. Now let's open our root.ts file. At the top, we will type import next response close curly braces from next/server. Then import auth from @clerk/next.js/server to handle our user sessions. Finally, let's import get db from @/lib/mongodb. Wait, we haven't created that library file yet. So let's go into our lib folder and create mongodb.ts. First, type import mongo client from mongodb. We need our credentials. So let's type const URI equals process.env.mongodb_URI. If that URI is missing, we will throw an error saying mongodb_URI is not set. Next, we initialize the connection. Type const client equals new mongo client, passing in that URI. Then const client promise dot equals client dot connect. To make this accessible, we export async function get db. Inside, we return a wait client promise dot db, and we will use our environment variable for the database name or default to career_campus_AI. Now, let's head back to our main route file to finish the logic. First, we set export const runtime equals node.js. We need to define what our saved data looks like. So we will create type persisted state. This includes our stage, profile, plan, selected month ID, and our chat array. To keep things safe, let's add two helper functions. First, function is object like. which checks if a value is actually an object and not null. Then, function is persisted state, which acts as a guard to ensure the incoming data has the right structure, checking for the stage, the chart array, and a valid month ID. Time for the get function. We type export async function, get, and start a try catch block. First, we get the user ID from Clark by typing const open curly braces user ID close curly braces equals await auth. If there is no user, we return a 401 unauthorized error. If they are logged in, we call const db equals await get db. Then we search our collection by typing const doc equals await db.collection user underscore states dot find one, filtering by that user ID. If no document is found, we return a state of null. Otherwise, we return the saved state from the document. Finally, let's handle the post request to save data. Similar to before, we grab the user ID and verify the session. We then extract the state from the request body and run it through our isPersisted_state check. If it is invalid, we return a 400 error. Now for the save logic, we call await db.collection user underscore states dot update one. This part is clever. We match by user ID and use $set to update the state and the updated at timestamp. We also use $set on insert to track the created at date only when a new document is made. By setting upset to true, MongoDB will either update the existing record or create a new one automatically. With this in place, our app now has a memory. Every career plan and chat message is safely stored in the cloud. Alright, let's dive back in. Now we are going to build out the handle onboarding submit function. This is the heart of our onboarding process, where we take all that user data and turn it into a concrete roadmap. Let's scroll down and start by defining our main function. We will type const handle onboarding submit equals an async arrow function that takes in a profile of type user profile. This is an asynchronous function because we will be making a network request to our API. Now, before we jump into the logic, we need to track our loading state. Let's set is generating plan to true. This tells our UI to show a loading spinner or a progress message while the magic happens. Next, we will open up a try catch block to handle our API call safely. Inside the try, we will type const res equals await fetch, calling our /API/plan route. We are using the post method here, adding a header for content type application/JSON, and for the body, we will use JSON.stringify, passing in that profile object. Once we get a response, we need to handle the data. Let's declare a variable letPlan of type plan. We will check if res.ok is true. If it is, we will type const data equals await res.json and cast that as an object containing an optional plan. Then we assign plan equals data.plan. But what if the API fails or returns nothing? We need a solid backup. Before we finish this logic, let's step outside the function for a second and create a mock generator. Up here, let's define const plan generation steps. As an array of strings, these are the messages the user will see, like analyzing your background and building your 12-month roadmap. This keeps the experience feeling interactive. Now, let's build the fallback function. We will type function generate mock plan, which takes in the profile. Inside, we will define const base themes as an array of 12 themes starting with foundations and clarity. all the way to launch and transition. Next, we create the actual months. We will type const months equals array.from with a length of 12. We use the index to determine the theme. If we run out of themes in our array, we will default to the string month followed by the index focus. Inside this loop, we are defining 4 tasks for every single month. Task 1 is learn and absorb. We use a ternary operator here. If it is the first month, index equals 0. We set the description to focus on clarifying the move into the profile.desired role. Otherwise, it is just a general learning block. We also add tasks for build and practice, connect with others, and reflect and adjust. Each task gets a unique ID, a category, and a default status of not started. Finally, we return the month object, and at the very end of the function, we return the full plan with a unique ID created using date.now. Okay, now let's go back into our main submit function and handle the else case for our fetch call. If the response was not okay, we will type console.error to log the failure and then set plan equals generate mock plan, passing in the profile. Now that we have a plan, whether from the API or our mock, we need to update our global state. We will type set state, taking in the previous state and returning a new object. We spread the previous state, set the stage to plan, attach the profile and the plan, and set the selected month ID to the first month in the array. We are also going to push a new message into the chat array. We will add an object with a unique ID, set the from field to Jake, and write a friendly message. Nice work, followed by the profile.name. We tell them we have mapped out a 12-month path toward the desired role. Alright, let's wire up the UI. We are heading over to our main render and dropping in the plan section component. This is where the 12-month roadmap actually comes to life for the user. We will start by typing out the opening tag, plan section. First, we pass in the profile, prop, which we pull directly from state.profile. This ensures the component knows the user's name and their specific career goals. Next, we add the plan, prop, setting it to state.plan. This is the big object containing all 12 months of data we just generated. Now, we need to handle which month is currently active in the view. We pass in selected month, which is our local constant that finds the specific month object based on the selected month ID in our state. For the interaction, we add onSelectMonth. This is an arrow function that takes an ID and calls setState. We use the spread operator on prev to keep everything intact, but we update the selected month ID to the new ID passed from the component. This is what lets the user click through different months. Next up is on update task status. We are going to pass in our update task status function. If you check the source, this function handles the logic of finding a specific task and toggling its status between not started and completed, while keeping the rest of the plan immutable. Finally, we add on start month and point it to our handle start month function. This is the trigger that officially moves a user into the execution phase for a specific month, likely updating their progress tracking. And just like that, our plan section is fully reactive and synced with our global state. This is it, the final piece of the puzzle. We are going to build a dynamic, high-end header component that adapts as the user moves from onboarding to their personalized plan. Let's start by defining the component. We will type export function header, and we are going to destructure our props, stage and profile. We will also define the types here. Stage is an app stage, and profile is either a user profile or null. Now let's start the JSS. We will open with a header tag, giving it a class name of space y3 to give our elements some breathing room. Inside that, we will create a container for our branding badge. We will type out a div with inline flex, item center, and a rounded full border. This gives us that pill-shaped look. We will use background card /80 for a nice semi-transparent background. Inside the pill, we add a span for the logo, giving it a primary background and bold text, CC, which stands for Career Compass. Next to that, we add another span for the text, Career Compass AI. Now, here is the first bit of logic. We will type curly braces, stage equals plan, and end. If we are in the plan stage, we want to show a special badge. We will add a small separator dot, then another span containing the sparkles icon and the text, AI-powered journey. This gives the user immediate feedback that the roadmap is custom built. Moving down to the main typography section, we will create a div for our headings. For the H1, we are using a beautiful background gradient to bottom right from foreground to foreground /70. We use background clip text and text transparent to make that gradient shine through the letters. Right below that, we have our paragraph tag. Again, we use a ternary based on the stage. If the stage is onboarding, we show a message about building the roadmap. If not, we show a message encouraging them to track their progress and let Jake guide them. Now, let's add the status chips that appear once the plan is ready. We will type stage equals plan and end profile. Inside this block, we create a flex container with a gap of 2. The first chip shows the target. We use the target icon and pull in profile.desired role. The second chip shows the time commitment. We use the clock icon and pull in profile.time per week. These little chips make the dashboard feel personal and data-driven. Finally, we close out our tags. Now, let's head back to our home page to put it all together. Just above our main content area, we will type header. For the props, we pass in stage equals state.stage and profile equals state.profile. And with that, the interface is complete. You have built a fully functional AI-powered career roadmap tool from scratch. We have reached the most exciting phase of the project, deployment. We are going to take this application live by configuring a virtual private server on Hostinger. Let's get started. First, we are heading over to the Hostinger landing page. We will navigate to Services and select VPS Hosting. Pro tip, if you want a massive discount, make sure to use the coupon code ALBERTAI at checkout to grab a killer deal. Once you are signed up and logged in, you will land on this dashboard. We are going to set up our VPS from scratch. Click that setup button. We can choose our server location. Let's hit next. And for the operating system, we are going strictly with Ubuntu. Now, we need to create a root password. You can generate one right here, but make sure you copy and save it somewhere secure. It is going to be super important later in the terminal. Hit next and finish the setup. This takes a minute to initialize. So while that loads, let's head over to GitHub. Our goal now is to create a Docker image and push it to the GitHub Container Registry or GHCR so we can easily pull it onto our VPS. Back in the console, we are going to use this command. This command tells Docker to build our image specifically for Linux systems without using old cached data and tags it with our GitHub repository path. Once that build finishes, you can see it in your Docker desktop under Images. Now, to push this to GitHub, we need permission. Go to your GitHub settings, scroll down to Developer Settings, and click Personal Access Tokens. Choose the classic method. Let's name this token Career Campus AI. For the scopes, we need to check the boxes for write/delete packages so we can actually upload our image. Generate that token, copy it, and keep it safe. Never share this with anyone. Now, back in the terminal, we need to log in. Type docker login ghcr.io, enter your GitHub username, and for the password, paste that token we just generated. Success! Now we can push our image by typing docker push followed by that long image name we created earlier. Hit enter and let it upload. Once it is done, you will see the package sitting right there in your GitHub profile. Now let's go back to the Hostinger dashboard. Grab your IP version 4 address. Open your terminal and type ssh root at and then paste your IP address. Type yes to accept the fingerprint and enter that root password we saved earlier. We are officially inside our server. First, let's update our packages by typing apt-get update. Next, we need Docker on the server. Type apt-get install docker.io. To make sure it is running, type systemctl is -active docker. If it says active, we are good to go. Now, we log into GitHub from the server just like before using our username and token. Finally, let's run the app. Type this command and then paste your GitHub package link. This maps port 3001 on the server to port 3001 in our container. If you visit your IP address at port 3000, the app is live. Everything works, the login, the Jake AI assistant. It's all running on a professional production server. Hostinger is a beast for this, so don't forget to use code ALBERTAI for that discount. Thanks for sticking with me through this build. It has been an absolute blast. See you in the next one.